Within a few minutes, we are going to start with the inaugural function of the 2 days national conference on Earth, Elements, and Energy, Interdisciplinary Perspectives. Ale? I request all the participants to please be seated in the auditorium and switch their mobile phones on the silent mode. Within a few minutes, we are going to start with the inaugural function of the 2 days national conference on Earth, Elements, and Energy. The guests for the inaugural function have arrived. A very good morning to one and all. For beginning with the inaugural ceremony, I invite the dignitaries on the dais to do the honor of lighting of lamp. I invite the dignitaries on the dais to do the honor of lighting of lamp and pay tribute to Dr. Panjabrao Alais Bhau Sahib Deshmukh and the social reformer Sant Gadge Baba. Dr. Panjabrao Deshmukh, the founder president of Sri Shivaji Education Society Amravati, was a visionary leader, educationist, and philanthropist. Sant Gadge Baba worked tirelessly for the social upliftment. We pay a humble tribute to these great visionaries.
Lighting of the lamp signifies the dispelling of darkness and igniting thoughts and enlightenment. As the flame ignites, it symbolizes the spark of energy within us, lighting with this light, we ignite the elements, earth beneath, air above, fire within, water that flows, uniting our energies to balance, renew, and illuminate pathways for a harmonious future.
Dr. Panjabrao Deshmukh, the founder president of Sri Shivaji Education Society Amravati, was a visionary leader, educationist, and philanthropist. We request the honorable guest to please be seated on the dais. To begin with, I, Dr. Sujata Kawade, welcome you.
And I, Dr. Anjali Bodade,
welcome you all for the inaugural session of the 2 days national conference on Earth, Elements, and Energy, Interdisciplinary Perspectives, jointly organized by the Departments of Chemistry, Physics, and Geology, held in this beautiful, newly renovated space,
the Ananta Infinity Hall, in the revered memory of Ananta, beloved son of our esteemed President, Dr. Bhausaheb Alais Panjabrao Deshmukh, founder president of Sri Shivaji Education Society. Ananta Infinity Hall symbolizes infinite potential, learning, and boundless spirit where horizons meet. This Infinity Hall will provide infinite opportunities for our students to excel in their life.
Today's conference is catalyzed by the DBT Star College Scheme and PM Usha, while sponsored by Sant Gadge Baba, Amravati University, Amravati, Amravati University Chemistry Teachers Association, OCTA, Amravati University Physics Teachers Association, OPTA, Association of Chemistry Teachers, ACT.
As Earth grounds, elements shape, energy moves. Let's spark a balanced future. Ladies and gentlemen, the elements align. The conference begins. We gather not just to explore, we gather to evolve. Moving towards the honorable dignitaries on the dais for the inaugural function, we have with us Honorable Chairperson Shri Dilip Babu Ingole, Treasurer Shri Shivaji Education Society, Amravati. Inaugurator Professor Dr. Shashank Maske, Director, Institute of Chemical Sciences, Marathwada Campus, Jalna. Chief Guest, Honorable Professor Dr. Mahendra Dhore, Pro Vice Chancellor of Santa Gadge Baba, Amravati University, Amravati.
Also on the dais, we are having the guest of honor, Honorable Dr. V.G. Thakre, Secretary, Sri Shivaji Education Society, Amravati, and our second guest of honor, Professor Dr. Subhas Chandrapan, FRSC, Department of Chemistry, Indian Institute of Technology, Guwahati. Also on the dais, we are having a respected principal of Sri Shivaji Science College, Amravati, Dr. G.V. Korpe, the convener of the conference,
Coordinator Dr. Sangeeta Ingole, Organizing Secretary Dr. Pankaj Nagpure, and co-convener Dr. Mayura Deshmukh. Once again, on behalf of the organizers, we extend a warm welcome to all the dignitaries and the participants.
Today's National Conference on Earth, Elements and Energy, the Interdisciplinary Perspectives, brings together chemistry, physics, and geology, which are the three core sciences that shape our understanding of the universe and address the critical issues in health, environment, energy, and sustainability. Chemistry fuels the advancements in medicine, biotechnology, and material sciences, whereas physics explores the principles behind everything from quantum mechanics to space exploration. On the other hand, geology reveals the Earth's history, natural processes, and the vital resources.
When combined, these fields unlock groundbreaking discoveries from nanosciences to physical to geophysical modeling and shaping a sustainable future. This platform invites scientists, educators, researchers, and students to share cutting-edge findings, engage in interdisciplinary dialogue, spark collaborations for real-world solutions by connecting experienced minds with emotions and build the collaborative spirit needed to solve tomorrow's scientific challenges. With this vision of connecting Earth, elements, and energy for a balanced future, we laid the foundation for impactful conversations in the coming 2 days National Conference.
Now let's take a moment to welcome and felicitate. For this, I request Principal Dr. G.V. Korpe to welcome the Honorable Chairperson of the inaugural function, Sri Dilip Babu Ingole, Treasurer, Sri Shivaji Education Society, Amravati, by offering a memento and a sapling. Welcome, sir, on behalf of the organizing committee of the conference.
I would like to request Honorable Shri Dilip Babu Ingole to felicitate the inaugurator of the conference, Professor Dr. Shashank Maske, Director, Institute of Chemical Sciences, Marathwada Campus, Jalna, by offering a shawl, Shriphal, memento, and a sapling.
Honorable Professor Dr. Shashank Maske is currently holding a position of a director at the ICT Marathwada off campus, and he is also additionally shouldering the responsibility as a dean of research and innovation at ICT Mumbai. Sir is a recipient of 7 patents. He has published more than 224 research papers, and he has received national awards for technology innovations in green polymeric materials and products. Welcome, sir, on behalf of the organizing committee.
Now I request Principal Dr. G.V. Korpe, sir, to welcome the chief guest, Honorable Professor Dr. Mahendra Dhore, Pro Vice Chancellor of Santa Gadge Baba, Amravati University, Amravati, by offering a memento and a sapling. Thank you.
Welcome, sir.
Thank you very much,
the
sir.
organizing committee. Now I request the convener of the conference, Dr. Prashant Mandlik, to welcome guest of honor, Honorable Dr. V.G. Thackeray, Secretary of Sri Shivaji Education Society. Welcome, sir. May I now request Honorable Dr. V.G. Thackeray, sir, to felicitate our guest of honor, Professor Dr. Subhash Chandra Pan, FRSC, from the Department of Chemistry, IIT Guwahati, by offering a shawl, Shriphal, memento, and a sapling.
We are delighted to announce that Professor Dr. Pan is a recipient of a DAE Young Scientist Research Award, Theme Chemistry Journal Award. He is a fellow of the prestigious Royal Society of Chemistry, member of Editorial Advisory Board of the Journal of Heterocyclic Chemistry, member of Tetrahedron and Tetrahedron Letters. He is a recipient of CRSI Bronze Medal in this year. Welcome you, sir, once again. To set the context and tone for our interdisciplinary national conference on
Jalna, Chief Guest, Honorable Dr. Mahendra Dhore, Pro Vice Chancellor, Santa Gadge Baba Amravati University. Other guest of honor, respected Dr. Subhash Chandra Pan, Professor, Department of Chemistry, Indian Institute of Technology, Guwahati. Our principal, respected Dr. G.V. Korpe, sir. Guest of honor, our guest of honor, Honorable Dr. V.G. Thackeray, sir, Secretary, Sri Shivaji Education Society, Amravati. Our principal, Dr. G.V. Korpe, sir, IUPAC Coordinator, Dr. S. Pingole, Madam, Organizing Secretary, Dr. Pankaj Nagpure, Dr. Mayura Deshmukh, all the dignitaries of the dais, dear delegates, research scholars, respected members of National and Local Advisory Committee, staff members, and dear students. Today on this occasion, and as a convener of this conference, it's my great pleasure to welcome distinguished guests, eminent speakers, researchers, and you all to National Conference on Earth, Elements, and Energy, Interdisciplinary Perspective 2025. Mark achievement representing the far-sighted vision of founder president of Sri Shivaji Education Society, Dr. Panjabrao Bhau Sahib Deshmukh. The conference aims to foster interdisciplinary dialogue among leading researchers, academicians, and scientists. The three foundational sciences shaping our understanding of matter, energy, and Mother Earth. It will definitely provide a proper forum where senior scientists, experts, young researchers, and scholars would get ample opportunities to interact and discuss interdisciplinary trend. The conference is catalyzed by the PM Usha scheme and the DBT Star College project and is Amravati University Chemistry Teachers Association, Amravati, Amravati University Chemistry Teachers. As all we know that the planning and grand success of such event is impossible without wholehearted, active, and unconditional support. So, on behalf of the organizing committee, I extend my sincere thanks to honorable guests, eminent speakers, senior scientists, the management of our parent society, members of the National and Local Advisory Committee, faculty members of the departments, participants, delegates, and students who have helped in planning and execution of this conference. The active involvement of Dr. Korpe sir and IUPAC members of the college is gratefully acknowledged. I express my sincere thanks to all the catalyzers, assigned grant, head of the various departments, faculty members, institutes, students, and administrative staff for their wholehearted support, directly or indirectly, for the success of this event. I am sure the deliberation during this conference would be meaningful and among the participants. I hope and encourage each of you to actively participate in the conference to learn and grow together. Thereby, the aim of interdisciplinary perspective will be fulfilled. Thank you very much.
Hello. Thank you very much, sir, for your introductory remarks. Dr. G.V. Korpe, sir, for his welcome address for the inaugural function.
And all. At the outset, I pay my sincere tributes to Founder President of Sri Shivaji Education Society, First Agriculture Minister, Dr. Panjabrao Bhau Sahib Deshmukh, Karma Yogi Gadge Baba, dignitaries on the dais, Chairperson for today's inaugural function, Dr. Honorable Shri Dilip Babu Ingole, Treasurer Sri Shivaji Education Society Amravati, Inaugurator for this conference, Dr. Shashank Maske sir, on a chief guest, Honorable Professor Dr. Mahendra Dhore sir, Pro Vice Chancellor, Santa Gadge Baba Amravati University Amravati, guest of honor, Honorable Dr. V.G. Thakre sir, Secretary Sri Shivaji Education Society Amravati, and also former principal of this college, Professor Subhash Chandrapan, Department of Chemistry, IIT Guwahati, dignitaries of the dais, I feel blessed to welcome you all on behalf of Sri Shivaji Education Society Amravati and Sri Shivaji Science College for this National Conference on Earth, Element, Energy and Interdisciplinary Perspective 2025. It's really a great to see you all here, young scientists, teachers, head of departments and principals who have joined us in this conference, and we know that you will something or some other way you will gain much of the things from this conference It will help you to understand various subjects. We have arranged this conference in the interdisciplinary manner so that chemistry, physics, and geology, they all are the mainstream subjects, and it will help you to deliberate whatever your findings, what your research is, whatever you do in your laboratories. And so we hope that your stay in Amravati will be a comfortable one, and we are there to serve you for 2 days. So I welcome you again. Thank you. Thank you very much.
Thank you very much, sir. May I now request the guest of honor, Professor Dr. Subhash Chandra Pan, FRSC, from the Department of Chemistry, IIT Guwahati, to address this inaugural session. Professor Dr. Subhash Chandra Pan.
Okay, so good morning. First of all, I respect Chairperson, Honorable Sri Dilip Babu B. Inglole, Treasurer, and then Professor Maske, Director of Institute of Chemical Science, and Chief Guest, Honorable Professor Dhore, and also the Principal and the Head of the Department, Maglik. So it is my first time to be here actually in Nagpur and then Amravati, and I got very privileged to be a keynote speaker here. And this kind of conference where the interdisciplinary is there, this is very important because ultimately we have to solve many challenges of the society, and that can be done by the cooperation of different fields like chemistry, physics, chemistry, biology. Okay, with one field sometimes some challenges is not possible. The challenges means solving the challenges is not possible. And so this kind of conference is important. Also during COVID, we did some online conferences, and that time there was no option because online only. But now the post-COVID era, though there is some online conference still going, but all of us agree with this physical conference. Because here you meet different persons, right? You interact with them, you exchange your ideas, and then you take photograph and it stays in your memory, right? So this kind of conference is important, and I hope that this 2 days conference will be fruitful and there will be a lot of discussions. Thank you very much.
Thank you very much, sir. The present conference has compiled a souvenir, which is a culmination of the abstracts of the participants from the 3 core subjects, that is chemistry, physics, and geology. I request the dignitaries on the dais to release the conference souvenir prepared by the organizing committee of the conference. Let's give a big round of applause for the release of the souvenir of the conference prepared by the organizing committee of the conference. The souvenir for the conference has been released by the dignitaries on the dais. Thank you all.
As we weave together the threads of earth, elements, and energy, I now humbly invite our chief guest, Honorable Professor Dr. Mahendra Dhore, Pro Vice Chancellor of Santa Gadge Baba, Amravati University, Amravati, to illuminate our gathering with his inspiring words. So please.
Firstly, I pay my homage to founder of Sri Shivaji Education Society, Amravati, our inspiration, Dr. Panjabrao Alais Bhausaheb Deshmukh. I also pay my homage to the great saint, Santa Gadge Baba, after whom our Amravati University is renamed. On the dais, the president of this inaugural function of National Conference on Earth, Elements and Energy Interdisciplinary Perspectives 2025, organized by this esteemed institution, Shri Dilip Babu Ingole, Treasurer of Shri Shivaji Education Society Amravati, the inaugurator of this national conference, Professor Shashank Maske sir, Director, Institute of Chemical Sciences, Marathwada Campus, Jalna, Society, Dr. V.G. Thakre sir, the keynote speaker for this very conference, Professor Dr. Subhash Chandra Pan, principal of this esteemed institution, and my friend Dr. G.V. Korpe sir, IQAC coordinator Professor Mrs. S.P. Ingole, organizing secretary of this conference Professor P.A. Nagpure, convener of this conference Dr. P.R. Mandlik, and Dr. M.M. Deshmukh from the Department of Geology and Geoinformatics. Of the dais, former Pro Vice Chancellor of Sant Gadge Baba Amravati University, Professor Jamode sir, Professor Mohril sir from Nagpur University, Professor Omanwar sir, Professor Berat sir, our colleague in the Management Council of Sant Gadge Baba Amravati University, Amravati, Professor Praveen Raghuvanshi sir, Professor H.S. Chandak, Chairman, Board of Studies in Chemistry, Professor Dr. Mrs. J.D. Dhote, Chairman, Board of Studies in Zoology, Professor Dr. Dinesh Khedkar, Chairman, Board of Studies in Botany, all the members of the various authorities of Sant Gadge Baba Amravati University, Amravati, my principal friends, Dr. Padole, Dr. Hande, my colleagues from Nagpur University, Nagpur, all the participant delegates of this conference, invited speakers, researchers, and staff members of this college, a very good morning to all of you. Firstly, I must congratulate and thank organizers for inviting me to be the chief guest for this national conference, which is planned very aptly as per is concerned. Dear friends, the theme is Earth, Elements and Energy. I see here there is a dominance of chemistry people in this conference because, and it is quite obvious because the secretary of this Sri Shivaji Education Society is a chemistry person. Principal of this institution is a chemistry person, and that's why it is quite obvious the dominance of the subject chemistry. But I am very happy to share with you all that whatever is the theme of this conference is very apt, and it is need of the hour to work on these lines. As we are advancing towards Vikasit under the leadership of our Prime Minister Narendra Ji Modi, and we are taking every care and effort regarding the green planet. So as far as the green planet is concerned, it is our responsibility being a citizen to fully cooperate for the cause, and we being the people from academic fraternity, that too specifically from the subjects or disciplines of this conference, we are having a more responsibility as compared to other citizens, and I suppose this is a platform which is between the generations, between the disciplines, between the institutions, and between the researchers and collaborators. I am sure whatever the deliberations will be taken place during these 2 days, those all deliberations will be very much fruitful from all of us, for all of us, and whatever deliberations will be taken place, I urge the young researchers to get actively involved in those deliberations and share your ideas and listen to the peers. Once again, I thank the organizers for inviting me to be a and I am very happy to share with you that Professor Pan, I am a fortunate alumni of this great institution. मोरील सर, तुमच्या माहितीसाठी सांगतो, मी या कॉलेजचा विद्यार्थी आहे, त्याच्यामुळे हा आनंद वेगळा आहे. So with these words, I once again wish all the stakeholders of this conference a great conference. Thank you very much.
We extend our deepest thanks to our chief guest for his infusing energy with his illuminating address. Thank you very much, sir.
Now, it's time for the much-awaited inaugural address of our Honorable Inaugurator, Professor Dr. Shashank Maske, Director, Institute of Chemical Sciences, Marathwada Campus, Jalna, for declaring the inauguration of this national conference.
Good morning to every one of you present here. First of all, it is overwhelming for me to give the address in the institute where my journey started. So I am also a proud alumni myself to be considered from Shivaji Science College. So dignitaries on dais and dignitaries off the dais. Dignitaries on the dais are also from my teacher side, and off the dais is also from my teacher side. Dear faculty colleagues too, few of them, those who have been studied with me during my Shivaji Science days or Amravati days. They are faculty into an Shivaji Science College now. My dear friends, those who have been studying into this great institution where the base has been formed so firm, which you can fly to any height which you wish to, which I can assure you, because I have been trained here, I have been inculcated the interest of the chemistry, which he rightly said there is a dominance of the chemistry here. But I was a student of the same subjects on which this conference has been laid on, which is physics, chemistry, and geology. So my combination was physics, chemistry, and geology. And I have been studied my geology, and that's the only geology which I have been studied throughout my career till today, but chemistry which I have been dealing to. As I have talked to you as a conference inaugurator, and that to be my institute, I have been delivered the talks into and certain conferences here, abroad, or in any other capacity. But this is the most honored for me to be amongst you into the institution where we studied, and still few of the corners are still been in the same glimpses where I can see that the Shivaji Science College is this. But rest of the things is completely revamped, sir. So we even can't recognize it where we have been studied and these were in the classroom. First floor was geology department, I don't know, now it's the same geographical location or somewhere else. As when too, I was even proud to be say that few of the students, those who have been studied in Shivaji Science College, Amravati University, they have studied in UDCT with me for their masters and PhD program too. So I was even able to guide to the student, those who have come from Vidarbha, that to be in the Vidarbha more specifically from Amravati, and in more specifically towards Shivaji Science. So that way my acquaintance with this institution is start with. Alma mater today, so I've been today standing in front of you because of my institution where I am been currently working as a professor. Rest all administration positions are been coming and going to, which all the time probably, at least in my purview or my understanding, I was not interested to. Few of them has been forced on me, which I have been doing it. So I am from UDCT, currently is a ICT. So it is a 90-year-old institutions, which we are been going to get it completed in 2033, which is 100 years of institution foundation. And we have two more campuses of ICT, which is one is in Jalna. So it is Institute of Chemical Technology, not Chemical Sciences. It is Institute of Chemical Technology, Jalna, where I am working as a director of that campus since 1 year now. That is the largest campus of ICT. We are not fortunate like IITs, the space which we have. In Mumbai, we have 16 acres of land, but Jalna is the biggest, which is 200 acres, which we have mobilized now and which we have been constructing. And why I have been talking to my institute and this whole scenario I have been giving you. So the conference title is Interdisciplinary Science. So interdisciplinary science is definitely a crux of the country, which is like Atmanirbhar Bharat or Make in India concept, which we are talking about the today's GDP and the increment of the GDP, where chemical GDP is contributing to 8.86 or something. So by that way also chemistry predominates the economy also. So definitely the chemistry deals with, professor is with material science and that way related to and converting to the activities for commercialization, not without side, and the geology which is earth science, and few more which is in pharma and biopharma. Interdisciplinary is a one, but now the current concept into and the research and the technology wherever into a national important institutions, organizations, or abroad into and certain other universities or R&D setups in India is not even been restricted or to them as an interdisciplinary. Now it has reached to multidisciplinary research activities. So more proven activities like multidisciplinary science and technology is supposed to be a more apt as compared to interdisciplinary. Interdisciplinary is nothing but your new education policy which we have been adopted in 2020 rather, and down percolated down to an technical education from 24 onwards. I don't know in higher education whether NEP has been taking it up. Their interdisciplinary is the core competence. So there is no interdisciplinary now into this. So in NEP you have your own core field and then you are anyway subjected to get into your core subjects areas also. So multidisciplinary, which is to be need of the country to convert any science or any technology into an translation research activity. We as an university, nation is demanding to generate the proof of concept, basic science, to be generated at the university level, institution level, and then this proof of concept to be delivered to an organizations where they can take it further to translation research. Nobody wanted an university or colleges to do the productions or set of commercialization, but to give an ideas and to an commercialization in proper direction, because we are open mindset. Industries knows their own fact much more in the depth. However, other than that of their subject area, they don't have the time or they don't have the inclination or their system don't permits whatever the way which you want to put forward. it's like they won't be able to do it. So, but we as a faculty, professor, researchers, we are open-minded. We can do any sort of research which is of our liking. So the piece of work which in any interdisciplinary science, this conferences or any other conferences per se, need to be create and some good platform which can be Mandlik sir and the food for a thought rather. I mean, everything may not be into a realistic picture because everything cannot be converted at their setup into complete reality. But food for a thought can be given to our young minds and hound them for their betterment in terms of the research and move towards the research. Getting it and good researcher at the younger team is also in the question mark. Getting it and for the student, for the PhDs are many. And sometimes as you've chosen yourself into an academics, so probably doing an PhD becomes the mandate to complete something, which I don't want to elaborate here. But really been taking it and a good stock for the getting it and good researcher, it is scarcity. You don't get it, at least I'm talking in terms of chemical technology and engineering. We don't get it as an ample number of students with the good mindset saying that which they want to do it as a research. Not because of the fellowship, not because of changing the brand from one university to other university. That kind of jumping jacks, you are getting it everywhere. But getting it with the good spirit to do it so, it's very difficult. So the student, those who are been attending this conference, offline, online, whichever mode it is for them. Many of them from whom I have studied as my chemistry part, which I have been practicing now. They have done their term, they have been doing it their term now also, which we are been doing it. Few of them are moving towards verge of completion of our term. So it is for the young mindsets, young students. So generally conference meeting gatherings is one part, which even Professor Pan also said that we supposed to have the offline one. Definitely the offline makes sense as compared to online. But offline conferences for we as an inaugurators, we as a chief guest, it ends up with some sort of event at the end. But taking it up is for the people, those who want to make their career in their subject area. So I wish them a best luck and I eagerly appeal to them to take it something from this rather than just for attending, not in physical presence or in mental presence. I am saying in the bottom of your heart, take people and the who's who from the academia, industry and the research organization which will be talking to you. So spend your time, complete 2 days in Amaravati with the conference. Rest all things in Amaravati. Amaravati is a beautiful city. I'm still been into and studied in ICT or into and Rutgers also. But I'm still been fond of my own Amaravati. I'm still been fond of my Raghuveer or whatever it is. So in the morning also I've been to the places where Amaravati supposed to visit. So you have the beautiful city where you have been landed. So please utilize this. And Shivaji Science College, Shivaji Society, to whom I owe to, any given time, Dinesh, any one phone call away, we will be at the services of yours and this organization and University of Amaravati any given time. Thank you very much. Have a great day. Thank you.
Thank you.
May I now request Honorable Shri Dilip Babu Ingole, Treasurer of Shri Shivaji Education Society, to guide us with the presidential address, setting the tone for our conference on Earth, Elements and Energy.
कर्मयोगी गाडगे महाराज ज्यांच्या नावाने अमरावती युनिव्हर्सिटी आहे सध्या, शिक्षण महर्षी कृषीरत्न आणि संस्थापक अध्यक्ष डॉक्टर पंजाबराव पाके भाऊसाहेब देशमुख यांच्या पावनस्मृतीस अभिवादन करतो. आजच्या या नॅशनल कॉन्फरन्सचे उद्घाटक ज्यांनी आपल्याला शुभेच्छा दिल्या, आमची अमरावती पहा अतिशय सुंदर आहे असे डॉक्टर शशांक मस्के. या कार्यक्रमाला प्रमुख पाहुणे म्हणून उपस्थित असलेले संत गाडगेबाबा विद्यापीठाचे कुलगुरू डॉक्टर महेंद्रजी ढोरे, ते ॲल्युमिनी आहे, याच शिवाय इथून शिक्षण झालं. प्राचार्य आहेत आमच्या नागपूर कॉलेजचे, आणि त्यांचे वडील शिवाई शिक्षण संस्थेचे आजीव सदस्य आहेत. आणि आमचं आजोळ मांगोळी असल्यामुळे आम्ही एकाच ठिकाणचे आहोत. माझ्या भावासोबत त्याचं झालं अरुण खुरत, आणि हे दोघे इथंच होते. दुसरे प्रमुख पाहुणे आहेत शिवाई शिक्षण संस्थेचे सचिव विजी ठाकरे, विजयराव ठाकरे. हे कॉलेज ज्यांनी उभं केलं, या कॉलेजचे ते प्राचार्य होते, आता सचिव आहेत. इथूनच कॉलेज मोठं झालं. आणि अजून मुख्य पाहुणे खास गुवाहाटीहून आलेत, श्री सुभाषचंद्रजी नाथ. आणि या कॉलेजचे प्राचार्य कोरपे साहेब नेहमी सुचूच देत नाही, काही ना काही करतच राहतात. त्याच्यावर संस्थे आम्हाला सगळ्यांना कामाला लावतात. असे प्राचार्य कोरपे, मंडलिक सर, इंगोले मॅडम, देशमुख सर, कोण राहिला, नागपुरे सर, आमचे जामोदे. आम्ही अंबावेटपाशी आहोत, ते जरी कुलगुरू होते तरी. आणि उपस्थित या कॉन्फरन्सला आलेले सगळे प्राचार्य, प्राध्यापक, संशोधक, येथे उपस्थित असलेले आमच्या विद्यापीठातले सगळ्यांची नाव घेत नाही, सगळे माझे प्रलिंग आहे. मी विद्यापीठातील मॅनेजमेंटवर होतो म्हणून सगळे खेडकर साहेब, आमचे सगळे प्राचार्य कॉलेजचे. आणि या कार्यक्रमाला उपस्थित असलेले जे स्टुडंट आलेत नवीन, मी त्यांना नवीन संशोधक म्हणतो. या कॉलेजचा स्टाफ, प्राध्यापक, प्राचार्य, बंधू आणि भगिनींनो, खरं म्हणजे मी काही सायन्सचा विद्यार्थी नाही आहे. फिजिक्स केमिस्ट्रीच्या चर्चा चालू होत्या, पण कसं आहे ना, आम्ही एक आर्ट्सवाले लोक याला शिकवत असतो, आम्ही नेते बनतो, हे प्राध्यापक किंवा हेच बनतात. आम्ही पदाधिकारी आमच्या हाताखाली, आता काही फरक पडत नाही. आणि खरं म्हणजे सर्वप्रथम आपल्या सगळ्यांचं शिवाई शिक्षण संस्थेतर्फे आलेल्यांचं स्वागत करतो. आणि मस्के सरांनी सांगितल्याप्रमाणे 2 दिवस आपले इथं आनंदात आणि चांगले जावं एवढ्या प्रसंगी बोलतो. खरं म्हणजे पहिल्यांदा 2 मिनिटात शिवाई संस्थेचा इतिहास सांगतो. इथे तुम्ही आल्यात, ही शिवाई शिक्षण संस्था डॉक्टर भाऊसाहेब पंजाबराव देशमुखांनी स्थापन केली आहे. ही 1932 सालची संस्था आहे, सगळ्यात जुनी. त्यावेळेस शिक्षण हे नव्हतं म्हणून शिक्षणाकरता उघडलेली ही संस्था शिवाई शिक्षण संस्था आहे. आणि आज या शिवाई शिक्षण संस्थेचा भाऊसाहेबांनी सांगितल्याप्रमाणे आज वटवृक्ष झालेला आहे. आज आमच्या शिवाई शिक्षण संस्थेवर 340 शाळा कॉलेज आहेत, मग कॉन्व्हेंटपासून तर वरपर्यंत. असं कोणतं डिपार्टमेंट नाही का जे आमच्यावर नाही आहे. आमच्याकडे ॲग्रिकल्चर आहे, पॉलिटेक्निक आहे, मेडिकल कॉलेज आहे, इंजिनिअरिंग आहे, BPEd आहे, BEd आहे. आणि हे सायन्स जेवढे कॉलेज इथं सगळे प्रिन्सिपल बसले अकोटचे. आणि सगळे आमचे कॉलेजेस जवळपास तालुका प्लेसमध्ये आहे. जे भाऊसाहेबांची इच्छा होती, अकोट असो, वरुड असो, तिवसा असो, मोर्शी असो, दर्यापूर असो, प्रत्येक ठिकाणी कॉलेज, चिखली असो, बुलढाणा असो, हे सगळे कॉलेजेस आहेत. हे जे सायन्स किंवा आर्ट्स कॉलेजेस आहेत. मेडिकल कॉलेज अमरावती आहे, डॉक्टर पंजाबराव मेडिकल कॉलेज. जेव्हा मस्के सगळ्यांनी सांगितलं, इथून आमचा भाग चालू होतो पुढं ॲग्रिकल्चर कॉलेजपर्यंत आमच्या शेतात. हे तुम्ही पाहू शकता. आणि अमरावती चांगले ठिकाणं पाहण्यात एक आमचं ठिकाण सगळ्यात सांगतो की आमचं जे भाऊसाहेबांच्या स्मृतीवर आम्ही केलं आहे पंचवटी चौकात, ते जरूर पहा. आपल्या कॉलेजच्या समोरच आहे. त्याच्यामुळं हा शिवाई शिक्षण संस्था इथे आहे. आणि आज इथे कोरपे साहेबांनी एक कॉन्फरन्स जे इंटरनॅशनल आहे, अर्थ, एलिमेंट आणि एनर्जीची कधी केलेली आहे. ते कोरपे साहेबांना खरं म्हणजे धन्यवाद देतो की अशा कॉन्फरन्सची आज गरज आहे. आता जास्त मी बोलणार नाही. आज न्यू एज्युकेशन पॉलिसी सुरू झाली आहे. ढोरे साहेबांनी सांगितले की मोदींनी पण चालू केलेला आहे. न्यू एज्युकेशन पॉलिसी जर भारताला नवीन ध्येय गाठायचं असेल तर नवीन संशोधक, नवीन सायन्स निर्माण करायची गरज आहे. आणि त्याच्याकरता आज काळाची गरज झाली आहे की अशा कॉन्फरन्स घेतल्या गेल्या पाहिजे. आणि कोरपे साहेबांनी कॉलेज घेतले. आणि यातल्या यात जसं ढोरेंनी सांगितल्याप्रमाणे आमचे सेक्रेटरी केमिस्ट्रीवाले आहेत, आमचे प्राचार्य केमिस्ट्रीवाले आहेत. तरी पण ही कॉन्फरन्स जी आहे आज केमिस्ट्री, फिजिक्स आणि जिओलॉजी, रसायनशास्त्र, भौतिकशास्त्र आणि भूगर्भशास्त्र यांचा संगम आहे. आमच्या या 3 शाखांच्या कसं आहे की कॉलेजमध्ये आपण आता डिपार्टमेंट हेड असतात. माझं डिपार्टमेंट चांगलं झालं पाहिजे, माझं डिपार्टमेंट चांगलं पाहिजे अशी कॉन्फिडन्स लागली पाहिजे. तर या कॉन्फिडन्समधल्या 3 लोकांनी संगम करून आज जो संगम झाला आहे, आज या 3ही लोकांचे इथे विद्यार्थी आले आहेत. जी भूगर्भशास्त्राचे अभ्यास करणारा आपण, केमिस्ट्रीचे रसायनशास्त्राचं आहे आणि भौतिकशास्त्राचा 3 मिळून. कारण अर्थ तुमचा विषयच तो आहे, पृथ्वी. आणि एलिमेंटचे पृथ्वीवर काय आहे, पृथ्वीवर भरपूर काही आहे जे शोधायचं आहे. एलिमेंट्स आणि एनर्जी म्हणजे ऊर्जा, सोलार बिलरचा जो प्रकार आहे, पर्यावरण आहे, ह्या सगळ्या दृष्टिकोन ह्या 3ही गोष्टीचा भूगर्भशास्त्र आज चर्चा होणार आहे, विषय समजणार आहे. नवीन विद्यार्थी आले, आपले नवीन प्रयोग मांडणार आहेत, पेपर लिहिला जाणार आहे. यातून काहीतरी नवीन निर्माण करायची गती जर या 2 वर्षात होईल. आणि यांना समजून आले, इथं सगळे मोठे संशोधक प्राचार्य किंवा प्राध्यापक बसले आहेत, हे त्यांना मार्गदर्शन म्हणजे नवीन संशोधक निर्माण करायची जबाबदारी या जुन्या संशोधन प्राचार्य प्राध्यापकावर आहे, या डिपार्टमेंटवर आहे. आणि या नवीन पोरांना नवीन चालना, त्यांच्या नवीन म्हणजे कसं आहे की आपले माइंड एवढे जुने झाले आपण, आपले माइंड सेट झाले आहे. या नवीन पोरांचे माइंड सेट नाही आहे. आज त्यांच्यात नवीन नवीन कल्पना आहे. या कल्पना आणि त्या चांगल्या होऊ शकतात, हे चांगलं आहे हे दाखवायची जबाबदारी आपल्या सगळ्यांची आहे. आपण हे सगळं कराल या 2 दिवसात असं मी समजतो. मी काही जास्त वेळ घेणार नाही. शिवाई संस्थेचा हा इतिहास आहे. या कॉलेजबद्दल सांगायचं झालं तर हे सगळ्यात कॉलेज 100 आपल्या भारतातल्या 100 कॉलेजात आम्ही 100च्या आत आहोत. A+ तर आहेत. आज आहे तुम्हाला हॉल पाहिला आहे, हे डेमिनेशन आहे. इथं रिसर्च सेंटर आम्हाला मिळालं आहे. छोटं आणि मोठं बारामतीचं जे आहे ते दुसरे आम्हाला मिळालं आहे, त्याचंही बांधकाम चालू आहे. शिवाई संस्थेतले कामं सध्या सगळीकडे सुरू आहेत. आणि आज जी न्यू एज्युकेशन पॉलिसी आहे ती हेच सांगते आहे की कॉलेजमध्ये आज एका कॉलेजमध्ये सगळंच मिळालं पाहिजे. सायन्सचे विषय, आर्टचे एका ठिकाणी सगळे प्राध्यापक पाहिजे. मी सायन्सवाल्याला आर्ट्सवाल्याला इथंच पाहिजे, आर्ट्सचा सायन्स पाहिजे, BEd इथं शिकता आलं पाहिजे. ही नवीन एज्युकेशन पॉलिसी आहे, ती राबवण्याकरता विद्यार्थ्यांना असं वाटलं पाहिजे की या कॉलेजमध्ये आल्यावर आपलं काहीतरी स्टेटस होऊ शकतं, इथं सगळं काही मिळू शकतं. त्या दृष्टिकोनातून शिवाई शिक्षण संस्था हेच कॉलेज नाही तर आमचे जेवढेही कॉलेज आहेत 35च्या वर आमचे हे सायन्स कॉलेज आहेत आज, तर या सगळ्यांमध्ये ह्या तयाऱ्या सुरू आहेत की सगळं डेव्हलपमेंट चांगलं विद्यार्थ्यांना कसं चांगलं शिक्षण मिळून त्यात चांगले संस्था. कारण नॅकचं जर तुमचं चालू आहे तर नॅकमध्ये आता पहिले प्रोत्साहन रिसर्चला दिलं गेलं आहे. तर रिसर्च म्हटलं म्हणजेच तुमचा संशोधनाचा अभ्यास आहे. रिसर्च करता तर आज नॅकचंही तेच आहे. म्हणून आमच्या सगळ्या कॉलेजमध्ये सगळ्या लेबॉरेटऱ्या चांगल्या होऊन विद्यार्थ्यांना चांगल्यात चांगला रिसर्च आणि नवीन संशोधन निर्माण करायचं कामं शिवाई शिक्षण संस्था आजही करत आहे. आणि याच्यात आम्ही या डेव्हलपमेंट, या न्यू एज्युकेशन पॉलिसीत साथ देणार विद्यापीठाची आम्हाला साथ असते, आम्ही नेहमीच करत असतो. आणि या डेव्हलपमेंटमध्ये या विद्यार्थ्यांचा कसा फायदा होईल एवढं त्या प्रसंगी बोलतो. आपल्या या कॉन्फरन्सला शुभेच्छा देतो. आपल्या सगळ्यांचे पेपर इथं चांगले होतील आणि यातून काहीतरी घोटून एक चांगला रसायन निघेल. आपल्या सगळ्यांचा एवढे विषय घोटून एक चांगला रसायन निघाला आहे. यातून काहीतरी नवीन प्रयोग निर्माण होतील जे देशाच्या फायद्याचे असतील. जसं आपलं स्वप्न आहे, भाऊसाहेबांचंही ते स्वप्न, इंडिया सगळ्यात चांगला झाला पाहिजे. त्या दृष्टिकोनातून भाऊसाहेब संवादन समितीतही होते. कालच आपण संविधानचा विषय घेतला आहे. त्या संवादन समितीत बाबासाहेब आंबेडकर, भाऊसाहेब देशमुखांनी निघालेले 345 कलमावर भाऊसाहेबांचं त्या किच्यात संविधानात हे आहे. भाऊसाहेबबद्दल सांगायचं झालं त्याचे पुस्तकं वाचाल तुम्ही तर भाऊसाहेब फार मोठं आहे. ते कृषी मंत्री तर होते, कृषी क्रांती त्याच वेळेस झाली, अधिवेशन त्यांनीच भरवलं. ह्या सगळ्या दृष्टिकोन तुम्ही अमरावतीत मस्केसर म्हणतात, अमरावतीत अंबादेवीचं मंदिर चांगलं आहे, अमरावती शिवटेकडी आहे, आमचं स्मृती भवन आहे. इथे जे VMB कॉलेज आहे विदर्भामध्ये सगळ्यात जुनं कॉलेज आहे. त्याच कॉलेज म्हणून त्या सगळे निघायचे. आमची संस्था ही सगळ्यात जुनी आहे. शिवाई कॉलेजचा हा भाग आहे. या पुरा परिसर इथं आमचे 19 कॉलेज आहेत. 4 ॲग्रिकल्चर कॉलेज आहेत, 4 सायन्स कॉलेज आहे, BPEd आहे, मेडिकल कॉलेज आहे, नर्सिंग आहे, पॉलिटेक्निक आहे, गर्ल्स पॉलिटेक्निक आहे आणि ॲग्रिकल्चर कॉलेज आहे, ग्रँटेबल आहे, हॉर्टिकल्चर आहे, बायोटेक्नॉलॉजी आहे. सगळा कॉलेज आहे, सगळंच काही इथे आहे. हा पुरा परिसर जर मधारला 1-2 भाग सोडले तर शिवाई शिक्षण संस्थेच्या हद्दीतला पूर्ण तुमच्या बोर्डापर्यंत डेअरी फार्म आहे, एनवी हाऊस आहे, ते शिवाई संस्थेत या सगळ्याकरता हा आमचं काम करायचं काम करतो. विद्यार्थ्यांना आणि पुढच्या दृष्टिकोनातून नवीन पिढीला जे भाऊसाहेबांनी स्वप्न पाहिलं होतं, संत गाडगे महाराजची समाधी समोरच आहे गाडगे नगरात. त्या ते निरीक्षक होते, पण त्यांनी समाजाला दिशा दिली होती काय केलं पाहिजे. त्या गाडगे महाराजांच्या नावानं विद्यापीठ आहे. ह्या विद्यापीठाचा भाऊसाहेबांचा हा परिसर आहे आणि या परिसरात सगळं एज्युकेशन चांगलं कसं होईल याचा दृष्टिकोन आम्ही पाहत राहतो. एवढंच या प्रसंगी बोलता आमचा इंडोर हॉलही मोठा केलेला आम्ही, इंटिरियर हॉल तोही तुम्ही पाहून घ्या. जाता आता मेडिकल कॉलेज समोरच आहे, त्याच्या बाजूला तेही तुम्ही पाहाल. फिजिकल कॉलेज आहे. एवढं या प्रसंगी बोलतो. पुन्हा एकदा या कॉन्फरन्सला शुभेच्छा देतो आणि आमच्याकडून काही थोडी बहुत चूक झाली असेल तर थोडं माफ घेऊन समजावून घ्याल. काही दुरुस्त्या काही असेल तर आम्ही करून घेऊ 2 दिवसात. आपलं 2 दिवसाचं अस्तित्व अमरावती नगरीत, कारण ही श्रीकृष्णाची नगरी म्हणून ओळखलं आहे ते अमरावती नगरी. इथून रुक्मिणीचं अपहरण जे केलं होतं देवीच्या मंदिरात तिथं भुयार आहे म्हणतात, म्हणून ही श्रीकृष्णाची नगरी समजली आहे. तर या नगरीत तुम्ही आल्या तर काही आमचं कमी जास्त झाले असेल खाण्यापिण्यात तर समजून घ्या, सांगून द्या. आपली व्यवस्था पूर्णपणे चोख होईल एवढी जबाबदारी घेतो. कोरपे साहेब हे सांभाळतील. एवढ्या प्रसंगी बोलतो आणि थांबतो. जय हिंद, जय महाराष्ट्र.
Thank you very much, sir, for your precious words and also anchoring wisdom in our gathering. May I now request the organizing secretary, Dr. Pankaj Nagpure, to propose the vote of thanks, expressing our gratitude to all the dignitaries, speakers, and participants for this inaugural function.
Honorable Chairperson of today's function, distinguished inaugurator, respected chief guest, esteemed guest of honor, Principal Sir, invited delegates, faculty, colleagues, research scholars, students, ladies and gentlemen. A very good morning to all. It is my privilege as a organizing secretary of this national conference, NCE3IP 2025, organized by Department of Physics, Chemistry and Geology, to propose the vote of thanks of this memorable occasion on behalf of the organizing committee. First and foremost, I express our heartfelt gratitude to the chairperson of the inaugural function, Honorable Sri Dilip Babu Ingole Sahib, Treasurer Sri Shivaji Education Society Amravati, for gracing this function with his presence and for his continuous encouragement and support to all academic and research activities of our institution. I extend our deep appreciation to our inaugurator, Professor Dr. Shashank Maske, Director, Institute of Chemical Sciences, Marathwada Campus, Jalna, for accepting our invitation and delivering an insightful address that set an inspiring tone for this conference. We are profoundly grateful to our chief guest, Honorable Professor Dr. Mahendra Dhore, Pro Vice Chancellor of Sant Gadge Baba Amravati University, for his motivating words and for his constant support to academic innovations and interdisciplinary research. On behalf of the organizing committee, I express our sincere thanks to our guest of honor and also keynote speaker of the conference, Professor Dr. Subhash Chandra Pan, Department of Chemistry, IIT Guwahati. Sir, we are excited to hear your keynote address. I also express sincere thanks to another guest of honor, Dr. V.G. Thakre, Secretary, Sri Shivaji Education Society, Amravati. We are truly enriched by your gracious presence, sir. I take this opportunity to express our heartfelt thanks to our respected principal, Dr. G.V. Korfe, for his guidance, encouragement, and continuous support in organizing this national conference. A heartfelt thanks to all invited speakers, delegates, research scholars, and students who have joined us from different institutions. Your participation adds immense value to this conference. We are wholeheartedly acknowledge the generous support received from PM Usha Scheme, DBT Star College Project, Sant Gadge Baba Amravati University, Association of Chemistry Teachers, Amravati University Chemistry Teachers Association, Amravati University Physics Teachers Association. Their contributions have greatly strengthened the organization of NCE3 IP 2025 and enabled us to provide a high quality academic platform to all participants. My special thanks to our convener, Dr. P.R. Mandlik, Head of the Department, Chemistry, as well as Dr. S.P. Ingole, IQAC Coordinator of the college, for their leadership, coordination, and dedicated efforts in shaping this event. I also acknowledge the sincere efforts of all heads of the departments of the college, faculty members, non-teaching staff who worked tirelessly to ensure the smooth execution of this function. Finally, a warm appreciation to the organizing committee, volunteers, all service providers, and everyone who contributed directly or indirectly to make this inaugural session a grand success. Thank you, one and all. We look forward to your active involvement in the upcoming sessions of NCE3 IP 2025. Thank you very much.
Thank you very much, sir. With this, we come to an end of the inaugural function of the National Conference. So with the permission of the chair, I declare that this inaugural function has been concluded. Thank you very much. After this inaugural function, we are immediately going to start with the technical session by Dr. Subhash Chandra Pan as a keynote speaker. I request the dignitaries on the dais to please be seated on the dais itself. So that we can immediately start with the first technical session by Dr. Subhash Chandra Pan sir as a keynote speaker. I also request all the participants in the auditorium to please be seated at their respective places as we are immediately going to start with the first technical session. I request all the participants, it's a humble request on behalf of the organizing committee of this conference, for all the participants to please be seated within the auditorium as we are immediately going to start with our first technical session by Dr. Subhash Chandra Pan sir as a keynote speaker. आपको पसीना आ रहा था मैम बीच में नहीं मैडम मुझे बहुत शुगर आता है नहीं शुगर ही नहीं है सेकेंड हेरिडिटरी है मेरा आइज भी रेड रहते हैं काही चुकलं नाही मॅम कोणाचं सेशनचे चेअरमन आहे ना त्यांना बोलवून घ्या वरती चालू करायचं सगळं बाहेर चालले हो मी तेच म्हणून राहिले की सुरू करू का सुरू करा I request all the participants to please be seated as we are immediately going to start with the first technical session.
all the dignitaries, invited guests, researchers, and the participants, please be seated. Soon we'll be started with the keynote address. A very good afternoon. Once again, I warmly welcome you all to the keynote session of the Earth, Elements, and Energy Conference. It's my honor to welcome Dr. Subhas Chandra Pan as our esteemed keynote speaker for today's national conference. Before he shares his valuable insights, I request the conference convener, Dr. P.R. Mandlik, to kindly give the introduction of our keynote speaker.
I request all the delegates and research students to take your seats as we are going to start our keynote address. Once again, good afternoon, you all. It is my distinct honor to introduce Professor Subhas Chandra Pan. Professor Pan obtained his BSc degree in chemistry honors in 2001 from Calcutta University and MS degree in 2004 from Indian Institute of Science, Bangalore. During his master thesis, he worked in Professor Govardhan Mehta's laboratory on the total synthesis of epoxyquinone natural products. He obtained his PhD degree in 2008 under the guidance of Professor Benjamin List at the Max Planck Institute, Germany. After doing postdoctoral studies at Harvard University with Professor E.J. Corey, who is a Nobel laureate known for developing retrosynthesis analysis, and at this Scripps Research Institute, Florida, with another Nobel laureate, Professor Glenn Michelzio, who is a leader in the field of organic synthesis. He joined Indian Institute of Technology, Guwahati as assistant professor in chemistry in 2011 and was promoted to associate professor in 2015 and a full professor in 2019. His research interest encompasses the development of organocatalysts as well as transition metal catalysts, diastereo and enantioselective reactions. During his research and academic journey, he is honored by various prestigious awards. CRSI Bronze Medal in 2025, DAE Young Scientist Research Award in 2012, Theme Chemistry Journal Award in 2018. He is a Fellow of Royal Society of Chemistry, FRCS 2021, member of Editorial Advisory Board of the Journal of Heterocyclic Chemistry, member of Early Career Editorial Board of journals Tetrahedron and Tetrahedron Letters. With his brief introduction, I am again thankful to Professor Pan for accepting our invitation as a keynote speaker, and I am equally grateful to Professor Sandipan Haldar, Professor VNIT Nagpur, for helping us to convey our invitation up to Professor Subhas Chandra Pan. I kindly request Professor Pan sir to start with his keynote speech. Thank you. Sir, please.
It's okay. Or yeah.
Thank you, Dr. Mandlik. And now I'm pleased to invite Professor Dr. Subhas Chandra Pan to deliver his keynote address.
So thank you, Dr. Malik, for the invitation and introduction. Again, it is nice to be here. So you can see the title of my talk, Chirality and Rings in Drugs. Okay. And this is important. See, we are eating medicine. Okay. So when you ask a class 10 student, okay, that who has given you medicine, he or she will tell you the doctor, right? The medicinal doctor. But but the preparation is not done by the medicine doctor, right? So it is the chemist people that make the molecules. So that we will see now. So, before the drugs, first I discuss the chirality. So, chirality is very important in the drugs also, so that we will see in a moment. So, chirality is a fundamental property of three-dimensional object. And chiral chemistry was identified by famous scientist Louis Pasteur in 1848, first time when he separated two isomers of sodium potassium tartarate. So what he found that the two isomers are identical in physiochemical properties but different in their ability to rotate plane polarized light. So this was an important discovery, and why he used plane polarized light nobody knows, okay, but he did the right things, and what he wrote, this is exactly what he told, okay, that I carefully separated the right hemiatrial crystals and the left hemiatrial crystals and separately observed their solution in the polarization apparatus of Mr. Biot. So Mr. Biot is a staff, okay, in his university. I then saw with no less surprise that happiness that the right hemiatrial crystal deviate to the right and the left hemiatrial crystal deviate the plane polarization to the left. And when I took from each of two kinds of crystals an equal weight, the mixed solution was neutral for light by neutralization of the two equal and opposite individual deviations. Okay, this is important. So this last one, that is the concept of racemic. Racemic means you use exact amount of right and left, and finally they cancel each other, so you get no rotation in the plane polarized light. And this is the crystal that Pasteur made. It is still there in the library in Paris. Okay. So this kind of crystals, okay, this called enantiomer actually, this right and left, they sometimes crystallize at different rate. Okay. Other properties are same, but crystallization rate may be different, and that's why he found these two crystals separately. And chirality versus acarity, that also we know. So although everything has a mirror images may or may not be superimposable, okay. So everything, if you keep a stand on your mirror, you get your mirror image, right, any object or something. And some molecules are like hands, left and right hands are mirror images, but they are not identical or superimposable, okay. So, you know, this is left hand and right hand. So you want to shake your hand, okay, right hand, you cannot shake with left hand of your friend, right? So that means what? There is a difference between right and left hand, right? So this is called the non-superimposable. So this left hand and right hand are mirror image of each other, but they are non-superimposable. So this brings the concept of chirality. For molecules, also there is a possible, like this one, this is carbon and 4 different substitutions, and it's mirror image like this, okay. And now you superimpose them, they are also don't align, okay. And for molecules, we tell them the concept of chirality. Other molecules like SOX, a SOX and its mirror image are identical. See, this is important. When SOX don't have this cut here, they are same. But when you put a cut, okay, then it's different, right? Then you have to put the one sock with your right leg and another sock. If there is no cut, then it is same. So, right, small things makes a difference. And a molecule or object that is superimposable on its mirror image is said to be achiral, like water molecule here. okay, oxygen and 2 hydrogen, the same substitution, and also you get the mirror image which is superimposable. So it is a chiral molecule. And all of us eat drugs, right? So it started long back. Earlier days we used to did not eat the molecule, but in 1957 these molecules came up, and particularly in Germany it was marketed. This molecule, if you see, these two molecules are mirror image to each other, right? Mirror image to each other, and they are non-superimposable. So that time these scientists did not thought about this, that the one will affect differently, another will affect another way. And so what happened, it was marketed as racemic mixture. You know, the racemic mixture means the 50% of this, 50% of this. Okay. So it was marketed as racemic drug because that time scientists did not know the importance of the other enantiomer, whether it is making some other effect or no. And it was marketed, and what later it has been found that it is the sedative properties. And this drug was given to pregnant women actually to calm nervousness. And this molecule, this R1, that has the desired property, but this one is toxic, birth defect. So if you eat together, what will happen? You will get the birth defect also, right? Because you are eating the toxic one also. And that is happened actually. Thalidomide is a catastrophic drug with tragic side effects. When thalidomide was taken during pregnancy, it caused birth malformation and death to babies. Okay, so a lot of babies passed away, and also some phocolumia that I will show you. So why it is happening actually? So actually when we are eating the molecule, it is interacting with some enzyme in your body, okay? Enzyme in your body, and they are also chiral. So what happens, the fitting may be different. So our enantiomer can fit the active site of a specific enzyme like a key for a specific lock, okay, like I show you the sock. And S enantiomer cannot interact with the same site due to defined arrangement. And it is a defined, but it can fit to a defined enzyme active pocket triggering a defined biological effect. See, if the other one does not have any effect, then it is okay. If it is neutral, no problem. Okay, then you can use racemic, no problem. But if the other one is toxic, that means it is interacting with an enzyme which is triggering toxic effects, right? Like blindness, birth defect, many things can happen, okay? Because it is interacting with other enzyme. And this already we know, the enzyme consists of this, which are chiral, right? Amino acid, nucleosides, carbohydrate, phospholipids, and the enantiomeric drugs will display different properties. So what happens, suppose this is a drug molecule we told earlier that these are the enantiomers, and it is an enzyme, okay? There is a pocket. So what will happen? A will bind with nicely B and C, but here it's the enantiomer cannot bind, right? So it is a poor fit, but it can interact, this one interact with other enzyme where it is fitting. You understand? And that will cause the problem if it has a toxic effect. So birth defects arose in 1961, and the medication was removed from the market, okay? So in Europe, this death means if some people die, they become very sensitive, okay? So the company then stopped this marketing drug, okay? Because of this tragic effect, and then they thought that what is the problem? Then they found that this, whatever I told, the AS1 has the toxic effect. So you see the 40% of the 10,000, right? That means 4,000 babies passed away, okay? And some people who did not pass away but they born with this phocomelia. That means your hand did not grow properly, okay? So this is a famous filmmaker, German filmmaker, Nico von Glasgow. produced a documentary called Nobody is Perfect, based on the lives of 12 people affected by the drug, which was released in 2008. Then you see this one. So there is YouTube video also of this person. He is a musician. He is Nigerian American guitar player, composer, singer, and songwriter who was born without arms. His mother took thalidomide while pregnant, which caused his disability. And he learned to play the guitar with his feet. Okay. So these are the tragic effects of thalidomide. So for many years, see, whatever story I told, that is 1960s, okay? So still long time passed. And then 1980 actually, there are some reviews, okay? Because people did not know. The company was not prepared to differentiate these two enantiomers, okay? Because company is a large scale production, right? So first in the lab you have to find what is the problem. So it was not, the company was not prepared, but they understood the problem. Besides the thalidomide strategy, another event that raised the importance of issues of stereochemistry, that was some scientists wrote, like manuscript stereochemistry, a basis of sophisticated nonsense in pharmacokinetics and chiral pharmacology. So what does it mean? It means the pharmacokinetics and chiral pharmacology, they are ignoring the stereochemistry, okay? So he told that stereochemistry is ignoring, and that's why people are suffering. This article and the series of articles that followed criticized the practice of conducting pharmacokinetic and pharmacodynamic studies on racemic drugs and ignoring the separate contributions. As a result, then there came this term that is the chiral technology. Okay, the industry people then took this strategy, chiral technology, emerged as the new era, stereopharmacology. So that came after 1984. And a more specific term, chiral pharmacology. So then they studied, then they realized that these two enantiomers, they are different entities, okay? So what you have to do, you have to separate them and you have to separately check their properties, okay? This is important. Before marketing any drug with a chiral center, you have to separate and you have to study their properties separately, and that came into the picture. And then they found that one can be talked as eutomer, another is distomer. Eutomer means one of them will show the desired property, right, that you want, and another which is not showing the desired property, that is called the distomer. And then the eutomer distomer ratio also you can see, okay. That is the is called the eutomasking ratio. That means the activity ratio actually. This is not there, this is will be 50-50, but eutomer activity, that is the showing, and how much less activity that is showing, that is called the eutomasking ratio. One way the eutomasking ratio is computed by dividing the EC50 or the IC50 of the eutomer by the same measurement of the distomer. So this way you can calculate. Okay, EC50 value of eutomer by EC50 of distomer. And this is the stereoselective toxicity that I already told, the other enantiomer. Okay, so you have seen the molecule, right? Now, not only that molecule, okay, there are plenty of examples where the molecules show different properties. Like the DOPA, okay, this is used for the treatment of Parkinson's disease. And this is enantiomer, right? Chiral center. And S-DOPA is the desired property that is restores nerve function, but R-DOPA is toxic. So what you should do eat then? You should eat the S-DOPA, right? Not the R-DOPA, because R-DOPA is toxic. Okay? So this you have to keep in mind. Similarly, this molecule, this is cytosymmetric molecule, SS-ethambutol, is effective for the treatment of tuberculosis. Okay, that is also very important. Tuberculosis, this one is the desired property, but this one, see, this is very dangerous. This is blindness. So that means if you eat together, then you will get blind. Okay, you want to eat something, but your effect is refined, right? So this is very important. This is another molecule. This is also enantiomer. The chiral center is there, and this is generally used for depression. Okay, in European or American countries, many people suffer from depression. So this medicine is used. That is the arfloxetine, and this is the molecule name, and trait name is defined. Okay, this is defined because this company gives the name of the drug, means the marketed drug, but the molecule name is same, independent of company. And this is another drug that is S-naproxen. It is anti-inflammatory agent. Okay, naproxen. This way you can get the tablet. But if you see the R1, that is very toxic to liver. And even this molecule is not, the R1 is not available, okay? Just 1 minute. Now, see, there are some things which you should know. The smell receptor in our nose, okay, they are also chiral, or the taste bud in your tongue, okay, that also can difference enantiomers because there is also chiral, okay, not only the enzymes in your body, many things are chiral. So like this one, S asparagine has bitter taste, whereas R asparagine is sweet, okay. That means if you want to eat some ice cream, right, with a asparagine, then it is bitter, right? You don't want, right? You want sweet. So what you will eat? The R1, okay? Similarly, this molecule, limonene, it has lemon smell, but this is orange smell, right? See, this fragrance industry is huge market, okay? Fragrance industry. So the fragrance industry also bother about enantiomers. Because this one, you see, S-limonene is lemon smell, R-limonene is orange smell, right? And if you mix them, then it is like it's not good, right? You get mixed smell. And here you see the S-carbon. This is also enantiomer. S-carbon is order of caroe, and R-carbon order of spearmint. Okay. So fragrance industry also care about the enantiomers. Now I come to the chirality, how it comes to a molecule. There are different kind of chirality. Whatever we discussed, that is the center of chirality. The chiral center is there. Now it can be chiral axis, chiral plane, helical chirality. Okay. And the presence of a chiral center in the molecule is not a sufficient condition for the existence of chirality. And the sufficient condition is the non-superimposable mirror image, whatever we told so far. So if it is a non-superimposable, then it is molecule is chiral. Okay, this is like some chemistry here. The chiral centers is present, and it is not only carbon. The sulfur, silicon, phosphorus can also have chiral center. Here molecules have axial chirality. Here you can see. Though there is no such chiral center, but there is a chiral axis, so the molecules can also be chiral. And this is planar chirality. Okay, there is a plane, benzene ring is there, but if the substitution, if it is there and some ring is there, then it can be also chirality. Now, see, we know the concept that the enantiomers are defined properties. Now we have to prepare them, right? Unless we prepare them, we have to prepare both of them and then see their properties. So there are few strategies which was known already, like substrate control, chiral auxiliary control, chiral reagent control, and asymmetric catalysis, that is the new. So first three methods require either valuable chiral reagents or chiral substrates in stoichiometric amounts, okay, which makes them expensive. And in catalysis, that asymmetric catalysis, what happens in catalyst, you need some mole %, okay, it is not stoichiometric. So what will happen? the cost of a drug will decrease when you use the asymmetric catalysis method, right? Cost of a method. And that's why industry will want, right? Because we don't want to eat expensive medicine, we want to use the medicine which are cheap, right? So you have to find the cheap method also. So catalytic asymmetric reactions are the most favorable and economical. And now there are three pillars of asymmetric catalysis: the biocatalysis, that is the enzyme mainly, but they have problem like disadvantage substrate specific sensitivity to high pH and temperature, unavailability of the enzyme for synthesizing the opposite enantiomer, and can you switch off this fan? So as you can see, there are three ways you can make, that is the biocatalysis, transition metal and organocatalysis, okay? Now there are defined advantage, disadvantages there. Like biocatalysis, that is enzyme, and enzyme you cannot modify, so they are available and you can use, but they are generally sensitive to high pH and temperature and unavailability of the enzyme for synthesize the opposite enantiomer, okay? We want opposite enantiomer also because that test should be done, right? And transition metal catalysis, they are broad scope, unthinkable transformation, but they are toxic and sensitive towards moisture, okay? That problem is there, they are disadvantage. But advantage is there are a lot of transition metals available, okay? And Nobel Prize was given in 2001 for this asymmetric transition metal catalysis. You can see here a phosphine mediated ligand, chiral one was used, and later he found that this chiral ligand, this one, this is C2-symmetric chiral ligand was used for this hydrogenation reaction, and this way you can make the DOPA actually. So that's why he was one of the scientists. He worked in a company actually, the Knowles. And then another two scientists, one is the Barry Sharpless. He used oxidation, okay, this chiral oxidation of allylic alcohol with this dead, that is easily available, diethyl tartaric acid. So this was the active catalyst, the titanium binding with the active catalyst, right, tartarate as well as the substrate. Okay, because substrate, this OH also is important. So titanium likes oxygen, okay? It binds with oxygen with the substrate as well as the reagent, and you get the chiral. And this is a Japanese scientist, he also discovered the hydrogenation reaction, particularly for ketone to generate chiral molecules, okay? Now what about organocatalysis? Organocatalysis, this is operate under mild condition, inertness towards moisture and oxygen, most of cases, okay? These are the advantage, but disadvantage is that there are only few elements like carbon, nitrogen, oxygen, phosphorus, sulfur, selenium, which are called the organo. Organo means they are molecules comprising on these elements would be called organic molecules, okay? And in 2000, Benjamin List, that time he was in Scripps Institute in USA, he found this reaction, that is the proline. All of us know proline, right? Proline is an amino acid, but there is a chiral center. So it was used at 30% and it can undergo the aldol reaction. And you get the product. You see the high enhancer selectivity. And in the same year, another scientist, his name is Macmillan. He worked that time in University of California, Berkeley, and he used this one. This is also amine catalyst. So this is secondary amine. This is also secondary amine, right? Only difference is there is only carboxylic acid, but here some other substitution like benzyl is there, another chiral center, and this is quaternary center is there. So these substitutions are there to control the geometry. Okay, when you generate this iminium ion, so how this will mediate the geometry, that's why these substitutions are there. And with this catalyst, he found this Diels-Alder reaction, and he found high enantiomer selectivity. So before this 2000, there was some reports are there on organocatalysis, but these two reactions revolutionized, means after that, lot of scientists became involved. Okay. So because of this, in 2021, they got the Nobel Prize for the development of asymmetric organocatalysis. This was the title of the Nobel Prize. And you see, he was that time in Amsterdam, but when he heard the news, he came back to his institute, and all of the students came out in the balcony and greeted him. Okay, now I will talk about the rings in drugs. Okay, this is also important, how the drugs looks like. We have already seen some structure. So mainly, the drugs have rings, and there are 351 rings and 1197 frameworks in drugs. Okay, and this was based on a review which was published quite few years ago in 2013. Okay, until that, 1175 drugs came into the market. An average of 6 new ring systems entered drug space. So he reviewed everything, what has been reported, what has come out as drug, and then he wrote that an average 6 new drug system, 6 new ring system enter drug space each year, and approximately 20% of new drugs contain a new ring system. So what does it mean? It means there is a scope of research. Okay, new ring systems you have to generate. So what is ring system, that I will show in a moment. Suppose this molecule, this will have 3 rings. Okay. So you cut this one also. So this will have 2 rings actually. This, and this is another. Okay. And what is ring system? Ring system is that this one is a ring system. Okay. So this is fused. You don't cut it. So this is a ring system, and this is a benzene is a ring system. And what is framework? Framework generally contains the ring system. This is there, right, already. And then you put this one, the whole molecule, but you can ignore the substitution. Okay. Now, this molecule, how many rings will be there? 3 rings, right? These 3 rings, 2 ring systems, and 3 frameworks. Okay. So these ring systems that are coming for the drugs, okay, new drugs, that 28% is new, okay. So that means you have to generate new ring system, and that the company will screen, okay, for new diseases. And this is the various ring system that is present in drug molecules, okay. That means benzene is present in maximum, then pyridine, then other heterocycles you can see. Right? So what is common there? Mainly the heteroatoms are nitrogen, oxygen, okay? Maybe some other heteroatom also there, that is not shown, like halogen, fluoro, chloro. What is also, you can see the ring, maybe maximum 4, okay? Maximum 4, 5, but there is not much, okay? And oxygen, nitrogen, what you see here, maximum here 4 nitrogen, okay? Oxygen maybe also 3, 4 like that. So you can understand the drug molecule structure. Okay, if you want to make some drug, your background idea should be clear. Okay, you should not make a drug which is like many rings are there, many oxygen, many nitrogen. Okay, because this is the history. What is history is telling is this. Okay. And he made also the review statistical data. So there are ring system, see 140 ring system, there is 0 oxygen, okay, or 0 nitrogen. That means only carbon, hydrogen. Now there are some drugs, ring system is there where there is 1 oxygen or 1 nitrogen, okay, or 1 other heteroatom. That is also there, but it is slowly decreasing, right? So 0 is maximum, then 1, 2, 3, 4 like that. And after 5, you don't see much, okay? So, see, this oxygen is finishing at 3 actually. There is very few ring system with 4 oxygens, okay? So the overall count of oxygen, nitrogen and hydrogen atoms in a ring system is usually not greater than 3, 4 and 5, okay? So oxygen is finishing fast. Oxygen is stopping at 3 and then nitrogen 4 and other heteroatoms can be 5. And this is the, over the years, how the drugs came into the market, okay? So in general, see, drug synthesis is a difficult problem and it takes a lot of time, maybe 10 years around, okay? And in general, 25 drugs come into the market, okay, every year. only, so this black one are the drugs that came into the market. Only 96 and 97, you see, it crossed around 40, right? So this is the golden year in drug discovery. That means this year the maximum drugs came into the market. Now, their frameworks, you can see accordingly their frameworks are also is defined high, okay? And the ring system also came like this. So this is the new frameworks and new ring systems, okay? So this is the drug scheme and this is their framework. So new frameworks and new ring system. That means that what I told you, that it contains the new ring system, okay, 28% of drug and new framework. So that is the data it is showing here. So this is also some statistics here. The ring system can cross therapeutic areas and target classes. If a ring system is reused, 62% are for a defined therapeutic area and 71% for a defined target class, okay? So this you know, when COVID came, then scientists used the earlier medicine because there was no remedy, right, for COVID. Because they thought that whether earlier medicines can be used, okay? Because of this history is telling that ring system can cross therapeutic areas, okay? But there are 204 ring systems and 901 frameworks that have only been used once in a drug, okay? Some ring system can be used for different therapeutic effect, right? Like you know paracetamol, okay? Paracetamol can reduce your temperature, it can reduce your headache, right? So its purpose different, okay? Means it can use for different purposes. Okay, so you now got an idea how the drug, okay, how the drug molecules should look like and whether you have to differentiate enantiomer or not, okay? So when chiral molecule is there, you should know which one you have to eat, okay? The R1 or S1. Now I come to the work, some work of our. So we work also chiral synthesis and catalysis, okay? So this was my first title. Here the cooperative title is there, cooperative iridium and Bronsted acid. So we have shown some metal and organo, but there are now in directions is going where the metal and organocatalysts can be used together. This is because of cooperation, okay? Cooperation is very important in life, right? So molecules also do cooperate. That means one molecule can do or can activate one molecule or one reagent and another catalyst can activate another molecule and then you get a product. That's what we are doing. Suppose a catalyst 1 and catalyst 2, they can be together and can convert A to B. Otherwise, it can convert first to an intermediate, okay? This is called sequential process. So suppose organocatalyst first convert to intermediate and then you use metal catalyst, okay? That can give you the product C. And this cooperative reaction, that transition metal that already we have seen, there are a lot of transition metals are there and organocatalysts, they can be used in cooperative and defined catalysis versions, it can be utilized, okay? So our reaction was a substitution reaction. all of us know substitution reaction, right? Now, whether substitution reaction can be done in chiral fashion. Now, this one, what it will go, the logic is that when you remove this one, it goes to allylic intermediate, okay? And the allylic intermediate, if it binds with your catalyst, okay, then you can get a chirality in the product. And that's what it has been discovered by famous scientist Eric Carreira. Now he is in Switzerland. So he published very many papers, and he used this ligand, and in a moment I will show iridium catalyst was used, and different nucleophiles. So all cases he got good product. And you can see also, I told you the allylic intermediate forms, and allylic intermediate, right, nucleophile can attack at terminal or here. If it attacks terminal, then you don't generate chiral center. But if you attack here, then you generate chiral center. And that's what the choice of metal is important. So if you choose iridium, then it is regiospecific. That means it attacks not at the terminal one, it attacks at the most substitute one, and you generate a chiral center. Okay, now there are some papers on de-aromatization, like here the naphthol is there, and if you have another substitution here, okay, then what happens, when you do a substitution, right, allylic substitution, you generate a chiral center. Now, if you don't have a substitution, then again it can aromatize, right? All of us know the aromatization is very fast if there is a hydrogen. But if there is a substitution, then you can generate a chiral center, right? And with this one, allylic alcohol also you can do, only phosphoric acid we have to use. Another one, that is the organocatalysis, means organ and metal. This is another version, intramolecular. So we thought to use this kind of substrate, okay, this alpha naphthol is there, and this CH2PH, and then this allylic. We thought to get a product like this, because this substrate was not reported earlier. So we first use this allylic acetate, okay, and we use first palladium and DBU base and different ligand, but as you can see, we don't get good enantiomer selectivity, but the diastole selectivity is good. Diastole selectivity means two chiral center, okay, and their ratio, but enantiomer selectivity is the enantiomeric excess, okay, how the one enantiomer is higher than the other one, that's called the enantiomeric excess. X minus y divided by x plus y into 100. Now, what the solution? One solution is that we can change the substrate, okay. We can get the product, that is the beauty of chemistry. We can change the starting material, but we can get the product same. Now if you use the alcohol here, because it is going same by the allylic intermediate. Now we put this alcohol here, and only thing we have to use a co-catalyst, which should be acid, so that this will eliminate, generate a allylic. But you get the same product. And here we got the success. So we use different acid, phosphoric acid, as well as this ligand. This we have to use for the iridium, that PN ligand, and phosphoric acid, removal of the OH as water. And we found that the chirality of the acid is not important. You can use the racemic acid also. Chirality of the ligand is controlling the molecule, the product chirality. So we got up to 94% enantiomer selectivity, and molecular sieve was used an additive. See, this molecular sieve sometimes can improve the enantiomer selectivity and the yield also. This is a point of research, how it is affecting, but maybe some interaction is facilitating, okay. And now, when you develop something, we have to show the scope also, we have to show different substitution, okay, that whether it is tolerating, and some cases you get less enantiomer selectivity because of some effect, right? You know that all groups has some effect here, plus R effect. So we get some cases less enantiomer selectivity like 76, and here we got 86, this is also 70, 88, 80%. So this is difficult to explain how the isoselective varies with the substitution. But this is of course some interaction it is affecting, right? And this was the mechanism that was proposed by Carreira, that first the double bond is binding with iridium, and then the HX is coming, water is eliminated, and allylic intermediate is formed. See, this is the importance. The allylic intermediate is binding with iridium, and iridium is binding with the chiral ligand. So what will happen? Your allylic intermediate is in chiral environment. Okay, that is the point. Now, if you add a nucleophile, it will do attack from one face, right? Because your ligand is there, so it is attacking from one face. You get the chiral center, and you get the product now, right? So in our case also it is similar, like this iridium ligand is first interacting, and then the substrate, the double bond. So double bond is interacting with the iridium, and the water is eliminated, then the allylic intermediate. So this intermediate is the main one, that the allylic intermediate is forming, which is binding with iridium, and after that the substitution reaction will happen. But that is with the dearomatization. Okay. So same reaction we thought to use on indole, and because indoles are very important, and you can see there are many molecules of indoles which are biologically active. Also the benzocarbazole, okay, that is another ring is there. Sorry, another ring will be this side. So here some medicinal potential is there, and some cancer relevance also is there. Now this molecule benzocarbazole, this we found actually in the reaction, though we wanted to make a chiral product, but this was the product that we got. So this is called benzocarbazole. So earlier literature we found that this kind of alcohol containing, it is known to give indole, the indole to benzocarbazole, okay? And what we found in literature, this is important. See, these cases, when they use the silver nitrate, they found that the spirocyclization product, okay? So indole, we know that it attacks from the 3 position, right? You attack and you get this one. Now, if you use a strong Lewis acid like silver triplet, what happens? This imine gets activated. And when imine gets activated, this bond breaks, okay? And this attacks at the 2 position here, and after some elimination of water, you get the benzocarbazole. So in our case also, we thought that whether we will get this one or this one. So accordingly, we prepare the substrate, and when you use the iridium and the ligand, and this is the phosphoric acid, achiral, and we found actually the ring means the benzocarbazole, no spiro product. Okay, that means the spiro product is forming, but when this mechanism you have seen, right? That was I told you. So it is getting activated, and then this bond breaks, and after that aromatization will happen. You get this compound. But as it is a new substrate and new product, this ethyl group will come from here. That we will show in a moment in the mechanism. We thought to undergo this project. As you can see here, palladium, iridium, cod, Cl2. And since it is a racemic reaction, we did not use the chiral ligand. So just iridium is enough, okay? And your phosphoric acid. So iridium, cod, Cl2, diphenyl phosphate, ethyl acetate, 1 hour we get this product. So this reaction is very fast, okay, because indole is reactive compared to naphthol. And you get quickly this product, and here only the yields are calculated, so good yields on defined substitution, as you can see here. Only these cases, when you have an electron withdrawing group at this position, then what happens? Indole gets deactivated. And in this case also, we found that some oxidized product is forming. So if indole is super activated, then problem, and super deactivated problem, okay, then you don't get the product. Because the mechanism tells that this acts as a nucleophile, right? This acts as a nucleophile and attacks to the allylic electrophile. So there should be enough electron on this ring so that a reaction can happen. And here the other part of our skin defined substitutions are checked and good yields are obtained. And then we thought to use another ring, okay? If you use another ring, right, naphthyl 1, then we get 5 rings, okay? This is also new product. And here's this side also we put another one, like instead of indole we use carbazole, then we got this one, and you see these rings are formed. And they have been found, they have photoluminescence properties, okay, that we wrote in the paper. Because there are a lot of rings are there, they can show the luminescence properties. And this is a large scale synthesis. And this is some derivatization reaction, okay. Here mainly this different halo substitutions or cross coupling. And this ethyl group also we converted to carbonyl, okay, means the ketone by a photocatalysis method. This one is here. Because some reviewer can tell what is the importance of ethyl, but when you convert to activated group like ketone, you can do many other functionalizations, right? So the mechanistic study that when we put a tosyl group, that means what? We pulling the nitrogen, right? So it is deactivated, tosyl. That is the sulfonyl group is there is no reaction. Now if we put a substitution at 2 position also, we get a spiro product. That tells the reaction passes through a spiro product. But we did not get, of course, the enhancer selectivity, otherwise we could have a paper here. And here we found the isolation of intermediate. If you do reaction for 30 minutes, then before the aromatization, we get this one. Okay, so this ethyl group is coming from this aromatization, okay, and some shift that we will see in a moment. So this is the reaction mechanism. Nitrogen, NH, yeah, first this one binds to iridium, then the acid comes, removes water, allylic iridium intermediate is formed, and now this B minus of the acid that can help in this substitution reaction. So you get the spirocyclic product, and after that, this nitrogen actually that is not shown, but it should be, nitrogen is activated by the acid, right? And you get the ring expansion, and after that, yeah. So dearomatic spirocyclation, ring expansion, aromatization of R, there's S, and then tautomerization, okay. Tautomerization is like here, and now 1,5 hydrogen shift, that is the aromatization. See, if there is a chance of aromatization, it will happen because it gets stability. Okay, that is the beauty of chemistry. So here you get the aromatization and you get aromatic product. So this is my group, current group members, and that is right side alumni. And I am thankful to the funding agency, and thank you for your kind attention.
Thank you very much. Thank you very much, sir. Your address was quite illuminating and refreshing for all of us. Now, definitely after this, while taking any medicine, we'll be thinking twice about the stereo of that specific drug. We truly appreciate the insights you have shared on harnessing elements for sustainable future. It was a refreshing lens on how elements hold the future of energy. Your presentation have thrown light on the role of a chemist as an architect of molecule, playing an important role in balancing future, and stereochemistry is their blueprint. On behalf of the conference, sincere gratitude for your time, wisdom, and inspiration. Thank you, sir. Thank you very much. Now we have announcements for the further technical sessions. Dear participants, please take a note. The next session of our Earth Elements and Energy Conference will commence shortly after the lunch at sharp 2 p.m. in the following venues. Physics session, Sir C.V. Raman Auditorium in the new building. Chemistry session, Ananta Infinity Hall, where we are present. Geology and Geoinformatics session, AV Theatre, which is just above the PGTD Department of Chemistry. Dear participants, do join for lunch, which is being arranged in a pandal near the college canteen. Thank you very much, sir.
Hello, 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 mic check, hello. A very good afternoon to one and all present here. On behalf of the organizing committee, I warmly welcome you to the National Conference on Earth, Energy, Elements and Energy Interdisciplinary Perspective 2025. This conference brings together scientists, researchers, academicians, and students from diverse disciplines, with the special emphasis on chemistry, the central science that connects Earth and its element to the modern energy solutions. From understanding atomic interactions to developing sustainable materials, from exploring green chemistry pathways to advancing renewable energy technologies. Chemistry plays a pivotal role in shaping a cleaner, safer, and more innovative future. Today's technical session aims to highlight these advancements that foster meaningful discussions that bridge theory, experimentation, and real-world application. Ladies and gentlemen, let us commence the session by welcoming our respected chairperson, Dr. A.S. Aswal sir, former professor and head, Department of Chemistry, Sant Gadge Baba, Amravati University, Amravati. Dr. Aswal sir is a renowned academician and an inspiring figure in scientific research. I request sir, please join us on a dais. Thank you, sir. I now request Dr. Nitin Bansod to kindly introduce our chairperson.
So good afternoon, present everywhere here. It's my privilege to introduce the session chairman and my guru, Dr. A. Aswal sir. Dr. Aswal sir is a senior professor and the former head of Department of Chemistry at Sant Gadge Baba Amravati University, where he was inducted as a founder faculty in December 1991. A distinguished academic, he earned his MSc with a third rank in 1986 and a PhD in 1989 from Nagpur University. His research expertise span coordination and solid-state chemistry, catalysis, molecular interaction, and environmental analytical chemistry. A prolific mentor, Dr. Aswal sir has guided 34 PhD and 15 MPhil students and authored over 199 research papers along with the 2 BSc final year textbook. He has successfully completed UGC-funded major and minor research project. His leadership roles include serving as a chairman, Board of Studies in Chemistry from 2012 to 2018, university coordinator for the Avishkar Student Convention more than 20 years, and convener of 19 national conference and workshop and 7 refresher courses. A respected figure in scientific community, Dr. Aswal sir is a fellow and life member of 14 professional societies and hold a key position in bodies like the Indian Chemical Society and the Indian Council of Chemists, ACT, and has elected as a sectional president, Chemical Sciences Section, 110th Indian Science Congress Association, Kolkata. For his outstanding contribution, he has been honored with the Utkarsha Seva Gaurav Puraskar in 1998 and the state level Shikshan Bhushan Puraskar in 2023. With this, I conclude and hand over the dais to the session chairman, Dr. A.S. Aswal sir. Thank you, sir.
Thank you, sir, for the insightful introduction. I request Dr. P.P. Raghuvanshi, sir, to welcome our chairperson, Dr. A.S. Aswal, sir, by offering a sapling and memento, a symbol of growth, knowledge, and sustainability. Thank you, sir. Now, it's a time, it is my privilege to invite our first...
अच्छा yes first we welcome
Now, it's my privilege to invite our first distinguished speaker, Dr. Hitendra Yam Patel, Professor, Department of Chemistry, Sardar Patel University, Vallabh Vidyanagar, Gujarat, to the dais. So, please. I request our chairperson to kindly welcome Dr. Hitendra Patel sir by offering a sapling.
Really my pleasure to welcome my own friends. With the long gap. Chalo bhai, photographer ho gaya. Sir, it's a official. इतने handsome आदमी है.
Thank you, sir. To introduce our eminent speaker, I now call upon Dr. Aswal sir.
आप बैठिए नहीं बैठिए आपको खड़े रहना आधा घंटा फिर. Good afternoon to one and all. It's really my honor and pleasure to be with you in this afternoon, first session of the conference, first technical sessions. And this is, I must declare here, this is my maiden visit after my accident after 14 months. And credit goes to again my own student, Prashant and Anjali. Because of their love and affection brought me here. Otherwise, I used to avoid little bit to go anywhere because of my major accident during the October 24th. So on this occasion, distinguished dignitaries, respected speaker, esteemed delegates, member of the organizing committee, dear participants, and my all dear student friends. At the outset, I welcome you all in this afternoon session. And at the same time, I must express my sincere thanks toward the organizing committee, as well as gratitude also for their meticulous planning, selecting such a wonderful speaker for the conference. Really hats up for your selections. All the speakers you have selected, particularly in the chemistry session, which I know, all the distinguished in their area of expertise, very simple, very accessible, and down-to-earth persons. And they are well known by their research only, not by the swar or names, throughout the globes also. So really, friends, this is an occasion, and as we know, rightly our anchor told that, we are moving from the knowledge-based society to the society of innovations, and therefore research is one of the important components. And chemistry made our world colorful, efficient, reliable, and specific also. And therefore contribution we cannot feel. And such kinds of platforms are very useful to encourage, to promote our own students in the areas of expertise, to explore their hidden talent, potential, and in order to face the global challenges, in order to meet the future demands of the people, society, we should do the work in such area that society can prosper also, and our life should be very progressive as well as the comfortables. And there is a role of chemistry. And on these occasions, I must congratulate once again the organizer for selecting a wonderful theme for the conference, which is really interdisciplinary themes. And chemistry, again, all we are knowing the central science associated with chemistry, biology, earth, engineering, material science. And so, mother of almost all sciences. And so, chemistry person is always coordinate with anybody, whether it is a medical science, engineering science, as well as the fundamental science. And therefore, we used to tell the basic science, engineering, and technology are the three important terms: knowing the things, doing the things, and applying the things. So, science, knowing the thing, engineering is doing the thing, and technology is the applying the things. And fortunately, we have all these three combination in these conferences also. So friends, we have the first speaker, and it is very difficult job for me after a such delicious and heavy lunch to catch the attention of the speaker. My job of you people are very difficult and tough also. So you should take care, and I know you are excellent teachers. So you will take care. So kindly bear with the speakers, and I take this pleasure to introduce our first speaker of the sessions. In all, we have 3 different talks in the sessions, and all are excellent speakers, including the Modi ji as well as Bhatte Sahab also. So let me take the privilege to introduce our first speaker of the technical sessions. Professor Hitendra Patel is one of my personal friends. More than the decade we have associated with each other on different platforms also. So Professor Patel is working as a full-fledged professor in the Department of Chemistry, Sardar Patel University, Vallabh Vidyanagars. And he was elected as a Organic Division Chemistry as a Royal Society member for the session 2023 also, and he has also admitted as a Fellow of Royal Society of Chemistry London in 2020. And he has several membership to his credit, and he has been extensively travel in India and abroad for delivering talks in the different conferences, in different panel also. So he is also closely associated with the different journals as an editor, as a reviewer of the different papers also, and he has also got the several award as a expert reviewer for the different journals. It is significant to find that he has more than 52 lakhs grants from the DST ACRB divisions, and important project from the government of USA also, and he earned several grants. And his area of work is very important in the synthetic chemistry, scaffold, drug discovery, medicinal chemistry, with the relevance to the green chemistry areas. So he has received Outstanding Contribution Award in 2018 for the reviewing of Journal of Molecular Structure, which is a very important journal in the synthetic chemistry elsewhere, and received a Distinguished Faculty Award in the 2017 also from the Venus International Foundation, Chennai. He has received number of awards as a Renato Delato Memorial Award in 2024, World Cancer Congress in 2024 at AIMS JNU Conference at New Delhi. He editorial Memorial Award for the 2024 also for the biologist and healthcare in Global Cancer Foundation. He has several MOU also regarding to his cancer drug discovery. And recently, he has also made one important MOU, I think, government of UK also, Oxford, and Biolab de Lengua, University of Spain also. He has published more than 75 research papers in the various journals, having very high impact factor and repute also. And it is very important for my young students that he has very good citation number, more than 1500 citation to his credit. H index is more than 27. I10 index is 41 also. So he started his career from small college to university level, and today is one of the important personality in the area of synthetic organic chemistry. Very popular speaker for the different conferences, closely associated with the Indian Council of Chemists and Biologists Society also. Every year he used to deliver a different address also. So since he has several contribution, again no need to read, everything is available on the website also. You may search also. But I must mention here one thing, though it is a little bit, is very accessible, and if anybody want to continue collaborate with him, is very simple researchers with simple laboratory, with simple chemical. He has developed a very good ideas in practice also. In short, he has green fingers to translate all his theoretical idea into practice. So with these brief introductions, once again I welcome sir and thank you for considering our request to come over such a long distance also. So now mic is yours, and your time is 30 minutes maximum. Since we are running behind the schedule, and in order to accommodate oral presentation, and other speaker otherwise will maybe anxiety to their talk also. So please take care, as I know you are well versed also. So please take care, and mic is in your hands.
Respected Chairperson and my very good friends, Professor Dr. Aswar sir, thank you very much for very nice introductions in short. And I also, thanks to the audience after taking lunch. It's a definitely great challenge to control the enzymes and must be activates them after the lunch. So friends, I initiate my talk. Before that, I would like to special thanks to the Shivaji Education Society and the principal of this Shivaji Science College and entire team for making a wonderful national conference and give us opportunity to speak something with the beautiful audience. So let's begin with my talk rather than wasting much more time. Hello. Yeah. So friends, I will discuss some of the important syntheses. The title is Diversified Heterocyclic Scaffold Enabling the Anti-Cancer Targets. I will cover the 3 or 4 different kind of reactions in which you will find the novel molecules And of course, we develop a new method also to catch some of the important molecules which shows the wonderful pharmaceutical applications. Okay. So outline of my today's talk is diversified synthetic protocols, which will cover the microwave-assisted synthesis of the dihydropyrimido 4,5-B quinolinones, and one-part stereo-specific synthesis of the pyrimidine ylidine acetates, and third series of compound, that is imidazole 2,1-B or maybe 4,5-B quinolinones, and the third one, that is a click chemistry, which is most favorable to the researchers nowadays for the focusing on the OTBN-based E1, 2, 3 triazole derivatives, and some miscellaneous based on the natural product, identify the phytochemicals from the natural species and their outcomes. I will share with you. So if I'm talking about the first synthetic protocol, microwave-assisted synthesis. Microwave-assisted synthesis of this quinolinone derivatives. So friends, I would like to mention you here the starting material, how they act as the important precursors to make the wonderful outcome in terms of the pharmaceutical applications. So friends, here, a pointer is not there, but you can understand here, this is the molecule which is very, very important to us. Let's see here, it is known as the Lawson molecule. It is known as a Lawson molecule. There is nothing but the 2-hydroxy 1,4-di-naphthaquinone. So this molecule, which is existence in the natural species, as we know, the henna plant, the leaf of the henna plant, in which we have these important molecules. Okay, and then another one is aldehyde, and the third one is nothing but the alkoxy derivatives of the 2-aminopyrimidine. So these are the simplest 3 molecules react together in a one port and will have the diversified molecules in a reaction mixture, and we isolated them as a 2 product, and we explored that which one is the most potent activity with the cancer cell lines. So friends, according to the literature, rather than wasting much more time in the introduction part, you can see here the main core, there is a quinoline core is there. In the every scaffold, during literature, we found out that quinoline can play the important role for such of the activities. As you know, one drug which is available into the market, which is called the camptothecin. It is existing as a drug molecule for the treatment of the cancer. And another also, you can have the variety of the applications in terms of the targeting the cancer cell lines. So my point is to, another point we also identified, there is nothing but the alkoxy functionality with respective positions on the main core is able to give the certain target activities. So that we also focus. There are several drug molecules which is existing into the market with the diversified that the inhibitory targets. So methoxy group also play the important role in the quinoline core, and you will find when we have to discuss some of the biological applications. One more key point I would like to discuss with you here, as I mentioned that the lotion is a very, very important molecule, act as a key precursor. But you can see that the diversified reaction protocol people are trying by taking amino derivatives of the pyridine as well as benzimidazole derivatives with the amine as a main functionality. They try to prepare this kind of molecule, right? We have collected those references and we understand why not cyclization happens. People didn't claim, even though they are using different reaction protocol, but they are not able to have a cyclization. And we thought that the orientation and reactivity, BSc people can know the orientation and reactivity, how we facilitate those kind of molecules. So we applied over here and we started these reactions. As we have seen that the diversified reactions, different protocols, they are not able to make this. Only they receive the CC bond and CN bond formation only. But here you can see, we use the microwave irradiations with using 200 watt and acetic acid as a catalyst, and within the 30 minutes during, it transforms into this mixture. And it's a novel for us when we receive the final product and there is a mixture, how we can separate it, why the mass of this product is high. And then definitely we receive that something better, as you know, the serendipity, how we catch those new molecules. Earlier report, you didn't found it, okay? So that's the things we learn from the literature. Rather than wasting much more time, in the optimization reactions we have the best solvent system we use, dual characteristic property, not only as a solvent, but it catalyzes the reactions also. Reflex condition 1.5 hours and 100% of the yield. So 3 to 6 entry, you will see here, there is 100% of the conversion is happened. And when we talk about the microwave assisted reactions, we use the power 200 and then the time is 30 minutes and the total percentage of the yield is 94 that we receive. And we use this protocol for entire reactions and we receive the number of derivatives. So the question is, at once reaction is completed, we have a mixture. And we found out the two spot in the TLC, how we can separate it. So we have systematically separated through the, automatic flux chromatography. At once we have to receive that the two spot is there on the TLC. We separated them and with the 50% of the ethyl acetate and 50% of the, oh, that's very good. Okay, both. It's difficult task. So, how I can? Okay. How can you operate? I can operate? Okay, from here. This is pointer. Okay. No, it will not. Huh? Also this side, this side. It is not working. No problem, no problem, no problem. No problem. Okay, so no problem. So hope you can understand. So that is nothing but we develop a TLC based on 50-50%, means what it is? 50% ethyl acetate and 50% of the NHexane. We found out this TLC, we just screen it, we have to insert it in the automatic flux chromatography and then automatically the solvent system taken and that is separated. So we collected the fragments, okay? Let us see another. So diversified substrate scope you will find here based on identifying the important functionality which is present on the core that we identified. As a methoxy, you will see here 1 methoxy, 2 methoxy, like that. Okay, with the different positions we have. When it's alkoxy functionality, it must be there on the carboxylaldehyde functionality where it makes the 2C bond and CN bond formation. So there is a 20 molecules we prepared. One more thing I would like to mention you here. When we separated these two spots, we found out the two products. One is a completely linear molecule, and another one is a non-linear molecule. Now the question is, linear one is better one for the pharmaceutical applications or the non-linear one? Let us see here. So I think the mechanism you can understand here, how we have. So as you know, this OH can play the important role to make the CC bond formation here, and then later on it eliminates the water molecule to have the Novanagel adduct, and then by interacting with the dialkoxy, 2-aminopyrimidine, okay, that can be interacted here, path 1A, where the CH activation is happened, as well as the CC bond formation. Then the intramolecular, ring closing step is take place to have a linear molecule. On the other hand, you can see in a similar fashion, but we can have a CN bond formation in a different manner by eliminating a water. You will see here the angular isomer. Okay, but a linear isomer which shows the better potency for the anti-cancer activity that you will learn it. So there is a huge small things we catch it during the course of reactions. You will see here when we take a LCMS mixture of the 5A and 5,6 that we separated, but in a mixture form, you will see here that the 430.5 is overlap here. So we use then, HMBC and HSQC, we use it and we identified that one is a linear, another one is a non-linear based on the heteronuclear multiple bond correlations as well as the heteronuclear single quantum coherence. We identify that these are the two molecules, which is linear and non-linear. So I will skip this. And then the question thing is the applications. We found out a 2 isomer, we separated when we characterize and confirm it, and then later on, you will see here, glioblastoma cell line. I think one slide is missing, glioblastoma cell lines. It is as usually, it's a normal cell. Glioma cell, glio cell, is act as a normal cell. But when the mass is deposited, then you will see that it's a tumor. But we can find out from the literature and the history of the report, 20% of these cancer in the brain, they based on the glioblastoma cell line cancer. And the 80% that is the malignant cancer when we are talking about the cancer on the brain. So with the help of my collaborators, we found out this important finding as a glioblastoma cell line target how we have. So, So here, I'm sorry. So friends, here, there is a 3 cell line, is there GBM6 as well as GBM22 and GBM143. So these are the 3 glioblastoma cell lines they use, and then you will see here the 5C and 5H we found out. Just I'm not discussing the other things, you will have the data, but 5C and 5H, that is a completely linear molecule which shows the best potency. So how we do this, that I will not discuss here based on this cell proliferation assay kit is also available, and about 20 molecules they screened together and they found out 2 is the best potent molecules. So here, let me try to explain. In this case, figure 8 clearly indicates here GBM6 cell proliferation was measured over the 5 days. Here, figure B, it indicates that the panel of the representative image of the spherical generated from the GBM6 cell lines, where you can see here there is a DMSO treated cell, here there is a 5H compound, and here this is a 5C. As you can see that control with the DMSO, how they spread the tumor. The cancer tumor is spread, but you can see here 5C and 5H, they control it. Okay, so let me try to compare with this directly rather than exploring all these things, but several study is provided by collaborators. I'm talking about one of the drugs which is available into the market, which is called temozolomide, TMZ, which is available into the market, and that drug molecule shows the 50 micromolar value, whereas our 2 compound, I'm talking about linear, that is 5C, it shows the best potency, that is a 3 micromolar as compared to the drug which is available into the market. So that's the study, that's the finding we found out. And you will find this work from the ChemCom publications in this manner. So hope you can understand 2 molecules out of 20, which is a very important target for these cell lines, okay, 2.9, and another one is a 3.3. So this is one series of compound and our finding. Let me another reaction, sir, please stop me whenever the time is over, because there is a huge things are there. So another reactions I would like to share with you. That is nothing but the Bigenelli reactions. As you know very well how we can carry out the Bigenelli reactions. That is nothing but the pyrimidine dione or thione. Pyrimidone, okay, so pyrimidine thione or pyrimidone derivatives are there in the core. This is the Bigenelli product I am talking about. We prepare as anilides, derivatives, then we treat with aldehyde, and then urea and thiourea, which is able to give us the Bigenelli reactions. As you know, 100 years ago, this Bigenelli was found out, right? And still today, the people are working and exploring that applications. We already published so many papers based on the Bigenelli reactions, but that product we utilize for the further organic transformation. Where it is, how it is, you will see this molecule. I'll show you the literature also. So when we have to interact with this one, simple one click, I'm talking about the methanol that we use as a solvent, and it catalyzes the reactions at the room temperature. At the room temperature, within 2 to 3 hours, we receive 20 molecules. Not only that, the 20 different molecules, we prepared it with the stereospecific synthesis. Here you will see that the Z isomer, we have it. And you will not find this kind of attachment on this. Otherwise, you will find this core, but the double bond and then COO-amine, you will not find in the literature that we did it. So we also explored that the fluorescent probe for the CD2, first time we identified with those molecules, because of course it was not there into the literature. So then another one I'm talking about, we also explored that the prostate cancer studies also with the help of by one of the collaborators, Vinod Kumar from the Chennai. Okay, so I will not discuss that much. But you can see, I will tell you that the students, whether it is master and MSc or maybe the researchers, friends, you can see the literature. This is the core thiazolopyrimidine, okay? The thiazolopyrimidine core is there with that recent literatures when we wrote a manuscript. You can see bigenyl product, aldehyde, and then chloroacetic acid. Is it fine? So here also you will find the same kind of things. We are replacing this and only another reactant, only two reactant which provides us the novel molecule, okay? And you can see here the diversified protocol they use, and they are not, I'm talking about the sustainable approach also. You can see here there is a reflux condition, right? We carried out these reactions at room temperature. Friends, I would like to let you know, whenever we have to design a new molecules, why not we carried out at room temperature? First we think about that, and then based on that you have to follow the gap chemistry, what it is, group assisted purification chemistry. The choosing of the reactant, it must be suitable to get easy transformations at a room temperature. Then only you think about the other alternatives. Okay. So friends here, okay, you will see here only two reactants. We are able to have this product, right? So I'll just show that optimization reactions. Methanol at room temperature within 2 hours, 97% of the yield. And according to the Paul Anastasia and John Warner, they are the father of the green chemistry. 12 principles of the sustainable chemistry we think about. Many of the people, they are claiming, oh, green chemistry, what it is? There is only green chemistry. There are only 12 principles. How many people can understand the 12 principles we are applying into our organic synthesis? At least we are able to fulfill the 6th protocol only. Then also you will find it wonderful things. So that is another protocol. I will skip this. So here also you can see that the stereospecific reactions, Z isomer only we receive directly, isn't it? Rather than using some specific catalyst, but we receive those kind of 20 molecules. And of course, we tried with the gram scale synthesis also, right? And we file a patent also on that. And this patent is published by the Indian Patent Authority. So that is the green chemistry calculation. It is easy to calculate the E factors. If our E factor, I mean environmental factors, if it is a 0, then it is absolutely perfect one, right? If it is increased 0.5, 0.8, then above 2, that means it is not sustainable fully. So there are so many criteria. I will not discuss that, and I will skip that. The mechanism also to cover the other things. Here we have, the good, prostate cancer cell lines. My collaborators provided this data. And then, of course, we found out the CD+2 ion, right? So that detections also we carried out with the help of Pinkesh Suteria from our department. And of course, whatever the prostate cancer cell lines, whatever the target we have, specifically for these two compound, MP30 and MP31, here MP39 and 43, they are most preferentially suitable for the prostate cancer treatment. So that's why we checked with the computational approach, and we found out that here the binding affinity that is there, minus 7.7 and 6.8. Here it is minus 8.1 and 7.5. So this work you will find with the Chem plus Chem, okay, from the Willy publishers. You will find that if you want to see that the details, you will get all this, the things. Now, another one I would like to discuss a little bit based on the, there is another derivatives based on the quinolones, okay, that we publish in the European Journal of the Medicinal Chemistry. So here also you will find the wonderful things for the target, if I'm talking about PDGFR inhibitors. What do you mean by the PDGFR inhibitors? Platelet-derived growth inhibitor alpha factors, right? So that we found out with the help of my collaborators, how it is, whatever the best molecule we have with the cell lines, whether it is glioblastoma cell lines or other solid cell lines, we found out the best potent molecule, and that best potent molecule that we screened with the, the kinase panel that was there in the Dundee University of UK. There is a 139 purified kinase were there, our two best molecules that screened together, and we found out that there is near about 1.25 micromolar activity with this best molecule. So I will not discuss that the introductory part. Hi, what happened? No, okay. So that is the thing, but okay. So friends, here we optimize the reactions. Another important molecules, vanillin, ice cream. Yeah? Okay, but the vanillin molecule is there by taking this benzimidazole, aminobenzimidazole, and this molecule. You will find this core, but attachment of the phenyl is very, very important to us for getting some targets. So friends, here we prepare this molecule by using ethanol at reflux condition. Within 1 hour only we can receive the 92% of the yield. And here also we file a patent for this. And these are the various substrate scope. Here you can see I think 17 molecules we prepared. And then mechanism I will skip it. Okay, let me try to explain. Here also we try to develop the method based on the gram scale synthesis. You will see that the white color product is there for the 4D molecules, and we receive 95% of the yield in the gram scale synthesis also. So friends, I'm talking about the PDGFR inhibitors, the kinase profiling that we carried out. You will see here our one best molecule 4P that will screen with this, the kinase panel which is available in the UK, Dundee University, UK. So here you will see that one of the important molecules which shows the 1 micromolar activity, and then with the different concentration you will see it is screened over here with the B. So I will skip this, the glioblastoma tumor cell lines, but you will see that a little bit the SAR which is shown here with this 4A2, 4Q. Here there is GBM22 cell lines, GBM6 cell lines, and here PDGFR inhibitor specifically that use either with the component or with the drug which is available as an imitinib into the market. So friends, here 1.25 this value we received. So similarly here also the computational approach also supported us to this molecule act as a drug likeness properties. And of course you can see here there is nothing but the blood-brain barrier permeability as well as the gastrointestinal absorptions, ADME tool, drug absorption, distribution, metabolism, and drug excretions that we carried out, and we found out here there is nothing but the 4P molecule is just P-glycoprotein-like substrate, and it shows the drug likeness properties by targeting the PDGFR inhibitors. And based on that, we have continued collaborations with the Dundee University, UK, and we made a joint ownership and management agreement based on this our work, and they are very happy. And now, at once the patent will be granted, then they will further process. They will invite the pharmaceutical industry, and they will explore that the further study based on this our finding. So it is confidential, but I am happy to share with my audience if they can learn it from this. So I'd be happy to this. So okay, so here you will find this work with the European Journal of Medicinal Chemistry also, and we filed the patent also. Very soon it will be published by the Patent Authority of India. Another click chemistry is there. Okay, just I will show you the reactions and some targets. Okay, sir. So here also you can see that the OTBN-based molecule that can be interacted with these alkynes. As you know, it's very famous reactions because the Nobel laureate who did this at the formation of the 1, 2, 3 triazoles. Okay, so friends, how this azide can be interacted with alkynes? I'm talking about. So this carbon attached here or this one, right? Either this side or this side. So the important role of the catalyst here, you will find there is nothing but the copper acetate that we use, and sodium ascorbate we use is, as you know, the copper, right? So in which state we are having, and then by adding, this sodium ascorbate, it converts into the copper 1 state, and then it makes the whole reactions, the acetylide form of this so here we have, and then finally the conversion. So I will not discuss much more regarding this, but optimization based copper 2 acetate, monohydrates, GMF and H2O. Within 15 minutes we have this 100% of the convergence. We develop the crystal also, and then we prepare this OTBN with this.
Patel sir,
yeah.
Kindly conclude.
Okay, I will conclude it. Okay. So I will not discuss that. Here we found out the STK33 inhibitory targets. I will skip this, and glioblastoma cell lines and their effectiveness. Okay. And not only that, just 1 minute, sir. Sir, there is a drug which is available into the market. Based on finding STK33 inhibitors with one component, we screened with the combinative approach with the existing drug molecules. Then also we found out that the things, okay, so I will skip this. And, Lord Shiva's fruit, okay. So from that we found out that the isofurocumarin derivatives, So one more good scientist, Gautam Brahmachari, who found out that isokumarin derivatives. Here we have another isomer we have. Okay, from this bill fruits, you know, sticky material is there when we have to cut and make a two-piece. It's very interesting and very good order is also there, and it is useful for the many things on our gastrointestinal tract, right? So we found out only one molecule by simply one method to grow a single crystal from the natural sources. Otherwise, you know, there is a huge molecules are there in a one species. Even though if you have to take a leaf of the plant, you'll get more than 7 or 8 phytochemicals. We found out this one molecules from this by developing a crystal only, right? Then we check the other parameters. So friends, here, I would like to stop here. Recently, one of the paper is accepted by the green chemistry based on the electrochemical that we first initiated to carry out this reaction, electrochemical, by purchasing one instrument. Okay, this is our first reactions, and we targeted this green chemistry. So that's why we are happy, even though, let me try to explain. I purchased this instrument by spending 48,000 rupees from my own pocket because of my interest. And we found out this first target. So that's why I'm so happy, and definitely we will receive the many things from that instrument in terms of a good publication. So there are huge publications, and here there is a review article. You know, bicycle. What do you think about cyclopropane? There are several protocols people are applying, different energy reactions, and how they transform the cyclopropane. Based on that concept, the synthesis is the journal from the first time they use this kind of graphical abstracts. So there are huge publications we have here. ACS Biomedchem, then ChemMedChem, we already discussed, Bioorganic Chemistry, ChemCom, RSC Sustainability. We received 10,000 pounds from the Royal Society of Chemistry as the RSC Sustainable Laboratory Grant Award, 10,000 pounds from the USA. So, and our work was cited by this Malarial World Newsletter also. Okay, we filed one patent is granted and 4 is in the pipeline. And thanks to the Sir Patel University, I salute them because of that wonderful destinations. We are growing just like a crystal since last 10 years. And then I'm thankful to the RSC. I'm thankful to my collaborators. This is my team. And then we arranged one workshop for the RSC Sustainable Laboratory Grant here with the team. And I personally he invited me at the University of Delhi personally to meet there for the celebrations of the 12 principles, 21st century of this. So they invited me, I met them, and this is my family also, and research family also. So thank you very much. Thank you, sir. Thank you very much.
Thank you, sir, for a wonderful lectures. So friends, since we are running behind the schedule, but till you have any queries, some quick questions. Yeah, I will be very happy, and our distinguished speaker will be very happy to answer your queries. 1 or 2. Yeah.
Otherwise, if you can have any other question, please.
In case of the triazole synthesis, I tried with the internal alkynes. Only terminal alkynes were working.
Yeah. So if I'm talking about the terminal alkynes, that is best fitted for getting a 1,4 disubstitution. 1,4 disubstitution. Okay. And if we have internal alkynes, then there may be the problem. Okay. But here we use the copper acetate. So the copper 2, that is converted into the copper 1 by adding a sodium ascorbate. And then we utilize this kind of the triazole formation. No, in that case, we didn't have a dimer. This is 1,4 disubstituted product. 1,5 is possible only when we have to use the other metals, not copper. Right? So that's why there is no question about this. We received only this one.
Any more?
Yes, correct. Yeah. Okay. Let me try to clarify in this matter. Of course, there is the ether linkage also that because we also work with the Visionary product, we have to have ether linkage from the aldehyde species to make this pyrimidine core. So that is nothing but whatever the alkoxy functionality we use it, where is the positions, what we have a resonating structures, Resonating structure is also important with having a moderate electron releasing group and strong electron releasing group. In this case, the moderate electron methoxy group and ethoxy group, they act as a moderate electron releasing. I'm correlate with the chemistry. But with the respective positions of this alkoxy group is able to show that property. When you have to go through all the molecules, then you will find whatever the best potency we have, which position is a preferential one. That you will learn it from the medicinal chemistry by the Foy book. So there is a huge SAR is also there. From that also you will find. Yeah, correct. Yeah. And so for finding a better potency, we choose a diversified that methoxy group with ortho, meta, para. Not only that, with the combination of OH and methoxy, that we also use it to check that where the efficacy we can have it. And we know very well how so many of the people, they are claiming computational approach. By computational approach, they are claiming, oh, this is my molecule which have we started. But we are not knowing how our cell will react with our molecule. That is, the result occurs, then only we can confirm it, how our cell molecule will interact with these molecules. Yeah, docking also we did it. Yeah. Yeah, they match together. The computational approach also supported to that fact. And that's why we only shown that the binding energy with those molecules, with those active molecules. Thank you.
Thank you so much, sir, for your enlightening and thought-provoking presentation. Sir, wait.
Arshali, you may call our next speaker.
Yes, sir. Sir, Felicity. I request Dr. P.B. Raghuvanshi, sir, Head Department of Chemistry, Brijlal Bihani Science College, Amravati, and Management Council Member, Sant Gadge Baba, Amravati University, Amravati, to felicitate Dr. Hitendra Patel, sir, by offering a memento as a token of love and gratitude. Thank you, sir. Moving ahead, I now invite our next esteemed speaker, Dr. Kushal Bhatte, Scientist, Catalysis and Inorganic Chemistry Division, CSIR NCL, Pune, Maharashtra, to the stage. I request Dr. Madhukar Dhande, Head Department of Chemistry, Mohta Science College, Nagpur, to welcome Dr. Kushal Bhatte, sir, by offering a sapling. Thank you, sir. For the introduction of the speaker, again I invite Dr. Aswar, sir.
Thank you, madam. Thank you, Vaishali. So, friends, again we have a very good speaker for these sessions. Kushal Bhatte is from NCL, who obtained his PhD from the ICT Mumbai Institute of Chemical Technology Mumbai, which is a deemed university, and who is also a very good researcher in the area of catalysis chemistry. And he has very wide teaching and research experience, more than 17 years, and several awards and honor to his credits. He has also very good postdoctoral research experience from KAUST, Saudi Arabia, and he is also with the Jeans Mary Bassett, is a well-known director in the synthetic chemistry, with whom our own student Vivek also worked for the more than decade also with him. And he has also patent to his credits and guiding the research student in the applied chemistry area. So through his research, you will know, he is again going to work on the catalysis and particularly ferrites also, nanocomposite, which are the well-known catalysis from Mumbai. Our Darshane sir started the area of this ferrites materials, who initiated his work at Institute of Science, Mumbai. Then Bhange sir, who is working presently as a Vice Chancellor of the MS University, Baroda also. So without taking much time, I welcome you, sir, and request you start your lectures, and time is start now, please.
Yes. So I would like to sincere thanks to the entire Shivaji College and the organizing committee to giving me this platform to share my research with you. Now my title of the topic is synthesis of isosteric acid using developed ferrite. That is one part, and the another part is green synthesis of nanosize Fe3O4 for catalytic application. So basically the work is divided into two parts. The first part is related with the process development for the commercialization of one of the important molecule from the industry point of view, and the other part is actually related with the fundamental. So the first part is oleic acid isomerization to get isostearic acid. Why we have chosen isostearic acid? All of you know that after the COVID, there are actually Make in India movement is actually growing on, and there are multiple molecules we need actually in India to get synthesized because they are actually imported from the abroad. So isostearic acid is one of the important molecule, and why it is important and how we are going to synthesize it. That is the outline. Now let me introduce isostearic acid. Isostearic acid is basically a branch chain fatty acid which comprises of C17 fatty acid chain, carbon chain, where there is a branching of CH3 group, and that CH3 group can be located from C5 to that of the C16. Now why it is so much important? The first thing is that it is non-toxic, it is having fantastic physiochemical properties, such as it is having low melting point. So even at low temperature, it can remain even in a liquid stage, and it has a large importance in the pharmaceutical, lubricant, as well as in the cosmetic industries. Now you can see that on the right hand side, there is a picture. There is an importance of isostearic acid. In 2024, the market cap of isostearic acid was nearly around $472 million USD, and as per the report, it is expected that it will grow in next 8 years around almost double. Its market cap will be almost double, and you can see the reference which actually shows its importance. Next is what are the current strategies to synthesize actually isostearic acid? There are two ways where actually it can synthesize at moment. First is clay catalyzed isostearic acid synthesis, where oleic acid is used as a raw material. Then there is a second raw material is actually vegetable fatty acid after thermal polymerization and its decomposition, and the final is carboxylation of olefin. However, all these steps, they are having associated with certain drawbacks. First, if you use oleic acid for using clay catalyzed, it's end up with several number of other byproducts. So their suppression becomes actually an headache, and it increases number of actually unit operation, and ultimately it increases actually capex and opex of the any industry. Now clay is also one of the important catalysis. The problem associated with it is that its recyclability and regeneration is not possible. So again, using a clay for the industrial important process actually becomes economically non-viable because of its non-usability. And the third is that though carboxylation of olefin is actually one of the route, there is no sustainable development of catalysis for this process. So towards the end, I can say that to the commercialization of isostearic acid from oleic acid, there is a plenty of scope to develop economically viable process using a new catalyst which can be regenerated, which can be reusable. At the same time, it can actually reduces the cost of overall process. So how we are coming up? In the literature, there are several patents where they have shown that ferrite, one of the important zeolitic material, can come up as an important catalytic material for this. All of you know, zeolites are silica aluminum material, and based on their actually interrelated structure, they are classified into the several families. FER is actually a two-dimensional alumina silicate molecule. However, it is a microporous material. Now, cost of ferrite. Cost of ferrite is an important actually the factor to commercialization of actually FER and its application towards the synthesis of isostearic acid. In the cost of FER, if we imported at moment, FER is imported from the Canada. There is only one USA company, Zeolyst, which is actually supplying FER in the market, and the cost of FER, which is imported from zeolite, at moment 1 kg goes more than 30,000 Indian rupees. So what we decided, can we synthesize FER in our lab at low cost, and actually it can get commercialized, then it can open the doors for the isostearic acid synthesis at different route at commercial level. Important thing in the FER synthesis is organic structure development, and that agent which actually organic structure development agent for the isostearic acid synthesis. What we decided, the cost factor for the FER is organic structure development agent. If we can remove that and actually can we resynthesize by some different ways, we can actually end up with its synthesis protocol or with a cost much less than what we are actually getting from the imported material. So how we come up with the strategy is that we utilize FER seed developed in our own lab as a seed for the further development of FER at commercial level. So this you can see that right hand side there is actually an autoclave which is around 50 liter capacity. We started initially with 50 liter capacity, synthesis in 50 liter capacity autoclave, and then we come up with this starting material chemical composition and utilize our own developed FER as a seed. And you can see overall process, downstream process. There is actually the conditions which is given. We initially carried out at hydrothermal synthesis 175 degrees centigrade for 1 day. Let me tell you, this is required nucleation growth process, and for that nucleation, people have reported more than 48 to 72 hours. We have reduced the time from 72 hours to 24 hours, which is also one of the key factors to make it more even essentially economically viable. Then we carried out from its sodium stage to that of ammonia state, and ultimately we actually obtained material when we heat it at 550 degrees centigrade, it ends up in the H+ stage, which actually act as a Bronsted acid. So to summarize here, that we have ended up in actually a process which not only reduces the cost but also reduces the overall time required for the FER synthesis. Now coming up the synthesis of isosteric acid. Whatever you are seeing at the left, at the top of the thing is actually an oleic acid, which is actually having a double bond between C15 to that of C16, and FER, that is our own developed catalyst, act as a material act as a catalyst. Now you can see that branching is developed. Now what exactly it happens? FER, it is a zeolitic material, it has a Bronsted acid sites. So when it reacts with a Bronsted acid sites, there is a carbocation formation is happening, and that ultimately turning into the stable carbocation, which actually generating a branching over here. Ultimately the obtained material branch unsaturated fatty acid, we are actually hydrogenating to get it that saturated fatty acid, which is nothing but an isosteric acid. Now this is an overall okay, this is an overall actually the scheme how we can you please can you go back? No, back you are this is better. I think this will not give fluctuation. You can see that how we have optimizes the condition. You can see that time, temperature, catalyst loading. Then there is a co-catalyst requirement for the same. TPP here is triphenyl phosphine. What is the role of triphenyl phosphine is that zeolite is having Bronsted acid as well as Lewis acid. When Lewis acid come in the picture, is give actually what kind of bisecting the product and smaller hydrocarbons are forming. To avoid that, what we did, we introduced TPP in the system. It acts as a Lewis bed. It masks actually the Lewis acid which are present on the surface of an zeolitic material, and it avoids side formation. And there is a water in the traces is also requirement because it helps to get Bronsted acid sites more available for the reactant. And ultimately, the one which you are seeing in the, actually the green condition, highlighted in the green, are the more actually the optimized condition. Now, this oleic acid generally which is available in market and the one which is supplied by the industry. Now, if we want to synthesize isosteric acid on a bulk level, then whatever available in a whatever available oleic acid feed is there, which was supplied by the industry, that we have to utilize. General oleic acid feed, which is distillated, is having more oleic and linoleic acid. But however, Godrej, whatever they supplied, their commercial one, with that we are getting the yield around 72%. So thing is that it works well with even what you called as less pure and market grade oleic acid also. Now, this right hand side you can see that our developed work, and left hand side you can see that the work which is actually developed in the Helen LGO group, and that is the US patent that they have claimed. We are actually more or less on the same platform, and that too we are using with our oleic acid of a market grade which was supplied by the industry. Rather, the work which is reported in the US patent, they are using more actually the purified oleic acid theme. So we can say that we are not only on the same platform, rather we are having an edge with our developed work. So to conclude that, here I would like, we have taken the patent, we have published the work. At moment, we are in the process to take the work on the next level. Now we want actually take this work not only limited to the lab, but we want to commercialize it. There are several, whenever any work which is translated from lab to that of any commercial level, there are TRL levels, technology readily available level. At moment, this work is actually 2 to 3 level. Now we want to take this work to 3 to 5 level, where we don't want to have only the proof of concept, but actually we want to show demonstration to the industry where its oleic acid to that isosteric acid synthesis at more than kg level with our catalyst, and that too with our recyclability. So these are the future challenges. We are working on it at moment. Scale up at kg level, we are actually going to do. Work is actually ongoing. We are actually making it more economically viable, so it actually can have as much as cost benefit possible. So not only it can actually attract the attention of any R&D labs, but also it can attract the industries which are currently having importance for an FMCG, industries like Godrej or any FMCG industries for its synthesis. And catalyst regeneration, we are working. Now my next work is green synthesis of nanosize Fe3O4. Why Fe3O4 nanoparticle are important? It are having lot of fundamental application as well as application in many different fields. You can see that then there are different synthesis routes are also given. Precipitation, thermal decomposition of any precursor, etc. However, all these materials are having actually synthesis routes are having their own actually drawback, requirement of high temperature, multiple chemicals. Then the chemicals which are used in the synthesis can actually limit their catalytic application, use of actually large time and temperature, so which makes ultimately process non-green. And already our earlier eminent professor Patel sir actually gave you the importance of green chemistry, so I am not going into much detail. So what we have developed our own protocol which can end up Fe3O4 synthesis by using only 2 chemicals, that too in a short time, and can give you a pure product with a high yield. So we have taken benzylamine and Fe acetate, we use microwave, and then in microwave we use actually carried out synthesis at 3 hours at 160 degrees centigrade, and ultimately once we get the product, we actually centrifuge it, dry it, wash it and dry it, and use for the further application. So what's the importance? It is one pot, one step synthesis, no calcination is required, and it is an energy efficient method. Once you get the product, it is free from any actually stabilizer or any other chemicals. So you can use it in catalytic application to the great extent. These are the characterization. I am just showing you that obtained material is in a nano material range. You can see the histogram which shows that they are actually, the TEM image and histogram shows not only in the, what you can say, uniform, but they are in a very good size, up to 10 to 20 nanometer range. This is an XRD which shows that it is actually FCC structure, well matches, and there is no peak of any Fe2O3 or FeO in that. Also, we carried out its XPS. It shows that it well matches with energy spectra of Fe2 and Fe3, which confirms its formation of Fe3O4. Now, this is the probable mechanism for the Fe3O4 synthesis. Benzylamine reacts with that of acetyl group of Fe acetate, and ultimately what you can see, rearrangement is happening. You end up with the benzylamide and ultimately ferrous hydroxide, which under microwave radiation it gives you Fe3O4. Now, just to support our proposed mechanism, we actually, what you can say, found out the existence of N-benzyl acetamide, which actually gives boost to our proposed mechanism. So this is actually the peak of benzylamide in a GCMS, which shows that proposed mechanism is actually, what you can say, our proposed mechanism has an evidence that it follows the same route. Now its application, we carried out its application for furfural to furfuryl alcohol. Why we chosen furfural to furfuryl alcohol application? Furfural is one of the biomass platform molecule which is available from the biomass. We are having plenty of biomass. However, once we have a furfural, it can be converted into furfuryl alcohol. That furfuryl alcohol is having industrially importance in, like what you can say, pharmaceutical, cosmetic, fragrances, etc. So we choose this process, and the beauty of the thing is that for this selective hydrogenation, there are double bond, carbon-carbon double bond and carbonyl double bond also. So here selective carbonyl reduction is carried out by using only solvent as a hydrogen source, and we have carried out at 200 degrees centigrade 4 hours under the pressure of nitrogen. So these are the optimized condition. We can see that we are getting actually the base still at 200 degrees centigrade. Then effective catalyst loading, you can find out that the 60 milligram is actually the effective catalyst loading. And here the solvent. We actually screen several solvent. Out of that, secondary alcohol, isopropyl alcohol, is found to be a more actually useful solvent for this catalytic transfer hydrogenation. The N-alkyl alcohol or primary or tertiary alcohol, they are not actually good as good as the secondary alcohol, because we know primary alcohol, they don't have a good what you can say, edge donation capacity, and tertiary alcohol also, they are not actually effective because of actually their steric hindrances. Now time, we found that actually 4 hours are more than sufficient to carry out the FAL converter, furfuryl alcohol yield in a good numbers. And we extended the scope of actually this work to the several other carbonyl compound, unsaturated carbonyl compound, and we can say that in Fe3O4 and isopropyl alcohol combination is actually can be utilized for the more actually carbonyl groups. And you can see that the Fe3O4, now in case of heterogeneous catalyst, suppression and regeneration actually the important things. You can see that Fe3O4 being magnetic, after the reaction you can simply apply magnetic force and you can actually separate it reaction mass from the reaction mass. And also we carried out its regeneration, recyclability, and it gives a good recyclability up to 3 cycles. However, we have actually carried out its recyclability up to 7. Though we have reported up to 3, it has given up to the 7, and it is actually with marginal decrease in the yield, it shows a good recyclability. And recently, this work has been published. This is the proposed mechanism where you can see that the Lewis acid and Bronsted site of the Fe3O4 comes into the picture. To confirm that their actually role, we actually carried out reaction in presence of another Lewis base and another Lewis acid. Once they mask actually this site, the yield of the desired product get decreases. So it supports our proposed mechanism. We also carried out energy of activation, and it comes around nearly 53. Of course, the energy of activation is actually minus 53, but we are actually showing its magnitude because the reaction is actually an exothermic. So to conclude, here I can say that our developed Fe3O4 not only actually having a low activation energy compared to the other catalyst, but low activation energy in literature, it has reported around 70 kilojoule per mole, and we are getting up with some what you can say 53 kilojoule per mole. It shows that our catalyst is also more active and efficient compared to the literature system. So towards end, I would like to say that we have actually carrying out research which actually can transform not only from lab scale to that of commercial level, and also we are carrying out research at fundamental levels. For this work, actually, I would like to thank my sincere thanks to Director of NNCL to provide facilities. I get immense support from my two senior colleagues, Dr. T. Raja and Dr. Vijay Bokade, and also the other two, they actually help in the development of protocol for characterization of isostearic acid, because isostearic acid is one of the tedious molecule to find out and actually quantify and qualitative. And FER synthesis, though that 50 liter capacity work shows in picture it looks simple, actually in reality it requires actually lot of manpower and actually immense work. So I got their actually contribution in that. And then the PA students, the name Akash Bhatkar, and I would like to tell that the Akash Bhatkar is actually an alumni, earlier BSc and MSc student of the Shivaji College of Science, Amravati, and he has immensely contributed in this work. So this is what you can say. I would like to thank Mandlik sir, because he has said that Mandlik sir has shaped his career, and that's why we have got a very good student in terms of him, and other students are also notified here. With that, I would like to thank and conclude my session. I hope I have finished within the time.
Yes, surely. Excellent.
Thank you very much.
Thank you, sir, for a wonderful lectures. You have covered a very important aspect. Most of our students are working in the area of material science, particularly ferrites, spinel ferrites, normal spinel, inverse spinels, and synthesis of ferrites is again sometimes difficult in order to get their purity and toward the nano size also. But you have developed an excellent method with the optimization of particular calcinization temperature, which play a very crucial role in this sense.
Thank you.
So friends, you have any queries regarding this? One or two questions, please, quickly.
Hello. Nice presentation, sir.
Thank you.
I have one query that you have synthesized the zeolite using hydrothermal treatment, na? Hydrothermal treatment. So you have dropped down the time from 24 or 72 hours to 24 hours. But did you ever try to decrease the temperature? That is also one of the challenging tasks for nucleation process.
Sir, yes, we are actually trying. Earlier, the temperature is reported around 220 degrees centigrade. We have dropped down to 170 because our aim is to synthesize FER as cost effective as possible. So whatever all the factors which contribute to its cost, like time, then the OSDA which actually adds since on cost, time, temperature, actually in terms of capex and opex come into the picture. So yes, we have actually worked on the synthesis also. Initial reported synthesis for is that 220 to 200. We have dropped down its temperature for the synthesis up to the 170. And along with not only we are actually waiting up to here, we are still modifying this process. We would like to, at moment, Our seed contribution for this, we have eliminated organic structure developing agent, which actually gives a zeolite proper structure. So we have eliminated, but we are using the seed. At moment, seed contribution is around 6 to 8%, depend on its nucleation time. We would like to bring that concentration, weight percent concentration, less than that of 2 to 3%. If we can achieve it, we can synthesize FER at what you can say less than 50% than that of the market available FER. If we have carried out its cost at moment, whatever the calculation we have made based on the synthesis, at moment its current appearing cost, which comes for 1 kg, is nearly 20 to 30% less than market imported catalyst. So we are actually in a process to make even the cost lesser than that. For that, not only the temperature, time, but we are also working on the other factor. So if we can provide FER to the something what you can say to the the plant or any industry, 30% to that of what you can say 40% compared to market available FER, this process will be viable, because ultimately the industry, what they look is actually the cost, entire cost. And also one of the tasks I said is the regeneration, because if we can regenerate the things, entire actually process will be more effective. But to what you can say, regeneration of 1 kg of catalyst, actually on paper is easy, but when it comes into the reality, make it entire catalyst regeneration is a bit challenging. Of course, the work is under process, and hopefully by year or 1.5 years, we will have entire technology readiness available up to the 4th, where we will have entire picture will be clear.
Another question, that means for nucleation process, which base is used? Either organic base or any inorganic base for?
No, we here in
And what should be the pore size and pore volume?
See, pore size, FER is having a big microporous, very, what you can say, small pore size, and that's why we need actually for the isomerization, we use the seed actually. Seed is actually eliminating this organic structure directing agent, which are actually no other than the pyrimidine and pyridine basis things. We have actually eliminated that. Instead of that, we use the FER seed, which was actually prepared in our lab. So that is the what you can say beauty of the work. And quaternary ammonium salts, etc. are reported, but we have not used. Instead of that, we have used the seed. That seed actually helps in the nucleation and its growth process, which actually aligns its in what you can say structure towards that particular frame actually.
So in first catalytic applications, you have talked about the branch structure,
Yes.
right? So easily escape out from the cavity because it is a microporous material.
Yes, sir. The kinetic diameter of actually, if you look of oleic acid and isostearic acid, it is less than that of the micropores of this FER cavity.
Generally, linear structure will be easily escape out from that cavity. Branch structure might be
Branch
difficult
structure,
to.
No, branch, you have to compare the kinetic diameter of both the products. Linear molecule can actually get out of any what you can say small pore. However, branching, what we are looking is the linear branching. We are not actually looking for something what you can say a more branch structure, where actually having its what you can say kinetic diameter very broader. Here the kinetic diameter is actually well within the range of a micropores of the FER. So we are getting, and if we use actually what you call, and to prevent further its branching or side product, we use actually the TPP as a base, which actually what you can say prevent the side formation.
Okay, thank you for wonderful explanations and discussion also. Friends, anyone amongst the audience? Because this is a very simple research area, how it is useful for the commercializations. Ferrites material, mixed metal oxides. So if there is no questions, I must acknowledge the speaker for a wonderful and lucid presentation of the nano-size iron oxide as a ferrites material, store the hydrogenation of furfural to furfural aldehyde also with the industrial applications also. So he has given several insight how one has to take care while preparing the green synthesis of the ferrites also. Sir, thank you once again on the organizers, and I request the organizer to felicitate.
Thank you very much, sir, for sharing your valuable insight. I request Dr. P.R. Mandlik, Chairman, Convener of the conference NCE3IP 2025, to kindly felicitate Dr. Kushal Bhatte by offering a memento as a token of love and gratitude. Thank you, sir. We now move to the final invited talk of this session. It's my pleasure to call upon Dr. Chetan K. Modi, Head and Associate Professor, Department of Applied Chemistry, Faculty of Technology and Engineering, the Maharaja Sayaji Rao University, Baroda, Barodla, Gujarat, to join us on the stage. Thank you, sir. I request the Dr. Hemant Chandak, Head, Department of Chemistry and Chairman of Board of Studies in Chemistry, Sant Gadge Baba, Amravati University, Amravati, to welcome Dr. Chetan K. Modi by offering a sapling. Thank you, sir. To introduce our eminent speaker, I call upon Dr. Aswar, sir.
Thank you, Harshali, once again. So friends, this is the third speaker of the sessions. And we have listened a very good lecture, earlier two lectures. And third is also more important and who is also young enthusiastic speaker for the sessions. Dr. Chetan K. Modi, whom I associate more than the 25 years when he was a student of his doctoral work also. He obtained his PhD from the Veer Narbat South Gujarat University, Surat in the year 2002 also. And he has very wide teaching and research experience, more than 25 years. And he has significantly contributed for the advancement of chemical sciences and technology in the government institute across the Gujarat also. He is very active member in order to promote the chemical research in the rural areas of the Gujarat also, actively associate with the science exhibition, different kinds of Vigyan Mela, Vigyan Bharati also. And Chetan K. Modi, basically he is inorganic chemist, but he shifted from the fundamental to applied work also slowly, and how one can molded ourselves from the fundamental to applied work also, and he is the best examples. Under his able guidance, more than 9 students got their doctoral degree also, and he has published more than 85 research papers in the different areas of very high impact factor journals. He has 21 H index, I-10 index is 42, and citations are more than 1300 also. He is very actively involved person in the applied chemistry areas, and presently is working as a head in applied chemistry division in Maharaja Sayaji Rao University, Faculty of Engineering and Technology, Baroda also. It is significant to note that he has also handled the several research projects supported by UGC, CSIR also, and DST also. I must bring to my young faculty that he has 3 patents to his credit, and some of them are also commercialized patent. So friends, under his academic leadership, and he is actively involved in the several outreach program of the university. As we know, in the NEP 2020, we have to make up all the activity in order to make students attractive to our subject, as well as the value-based education also. And he is a very good mentor in outreach area also. Several award for the outstanding publication, impact award from the faculty level, MS University Baroda also, distinguished subject experts recognitions, then outstanding journal review recognition awards also for various scientific publisher also. And his research is particularly the coordination chemistry, graphene supported heterogeneous catalysis, graphene carbon nitrides, silica based porous solid supported ionic liquids also, and one of the very important is the photoluminescence material, carbon materials also. And today he is going to very good topic. Nowadays it is a very hot cake in the present areas of the research, particularly graphene supported nanocatalysis. So without taking much time, I request Dr. Chetan to start your presentation, and time start now, please.
Thank you, sir, for your nice introduction. I'm most thankful to the organizer for giving me an opportunity to present my work here. As per the theme of this conference, I have chosen this topic, that is graphene supported nanocatalyst bridging Earth's element for a sustainable future. Now, before I start my presentations, first I will introduce my university where I came. The Maharaja Sayajirao University. The Maharaja Sayajirao University was established on 30th April 1949. So it actually evolved from the Baroda College, was founded by the late ruler Maharaja Sayajirao Gaikwad III, okay, in 1881. Okay. So the university was actually established by the Maharaja Pratap Singh Rao Gaikwad, the last ruler of Baroda state. So fulfilling the long held dream of his grandfather, that is Maharaja Sayajirao Gaikwad III, to create a center for higher learning in this region. Okay. So after its inception, MSU Baroda has grown as one of the India's foremost multidisciplinary university, which celebrated for its academic culture and impactful research endeavor. The university, which covers a total area of around 275 acre land, with one main campus and 5 satellite campuses are spread throughout the cities. And the university with 112 departments and 14 faculties, which serves around 46,000 students annually across the undergraduate, postgraduate and doctoral programs. So the university is renowned for its academic excellence, research contributions and cultural heritage. So now coming to the topic, it is not. So as the theme of this conference, now look at this, the globe scenario. So the globe today, where the air pollution, which is considered to be a major threat to the environment. So there are various pollutants like particulate matters, carbon monoxide, ozone, oxides of nitrogen, sulfur dioxide, and so on. These are various pollutants. According to WHO, 99% of the global pollution which is exposed to air pollution. Recently, we are facing that problem in the North India, specifically Delhi NCR, where like Greater Noida in Uttar Pradesh, with the average annual particulate matter 2.5 level, which is more than 600 microgram per meter cube, which is almost 10 times higher than the permissible limit, making it the most polluted city in the world. Next. Now, the second one, that is disability adjusted life years, which is nothing but the number of years lost due to early death, disability or disease, which is popularly used in the health impact assessment. So according to WHO, unintentional exposure to the hazardous chemicals between 4,270 to 5,400 every day, which is considered to be a threat to death. Globally, around 54% of the burden of the disease attributable to the environmental pollutions or environmental exposure, which is expressed in disability adjusted life years. So which is born by the children under the age of 15 years. The recent data, as per 2024, UNICEF, which has had raised concern on the impact of lead pollution. So on the health of the children, which is in its report, that is Toxic Truth, at least 1 in 3 children, up to approximately 800 million globally, have lead levels of around 5 microgram per deciliter. So lead exposure accounts for approximately 9 lakh deaths annually as per the data of WHO. Now next. Now coming back to my topic. So what is the role of catalyst? So catalyst is generally used in various sectors, specifically petrochemical industries, pharmaceuticals, automobiles, fine chemicals, polymers, surfactants, petroleum refinement. So what is the actual role of these catalysts? Where the catalytic converter in vehicles, as we know that the exhaust coming out from that vehicle, it consists of various pollutants. So the role of catalyst, it can convert into harmless chemicals like nitrogen, oxygen or water, which is also used as a selective catalytic reduction in power plants to reduce NOx to N2 and water. So this is the method through which the power plant industries, one of the pollutants like oxides of nitrogen convert into nitrogen and water. Catalyst is also used in oxidation of VOCs, volatile organic compounds, which is also used in wastewater treatment, catalytic ozonation and many more. Next. So the broad classifications, as we know that catalysts are two types, homogeneous and heterogeneous. So homogeneous, they are of having several advantages. Along with that, they are of having major disadvantages. So for ease of dissolution, however, the separation difficulties that generally arise in homogeneous catalysts. On the other side, the heterogeneous catalyst, which can be recycled for a number of times. Okay, so while using heterogeneous catalysts, the minimized use of potential hazard, reuse and recyclable for a number of cycles. Less energy consumption, and which is also economic and feasible. Next. Okay, next. These are the various solid supports like natural clay, zeolite, silica, polymer resins, MOF, carbonaceous supports. So among them, we have used the carbonaceous supports. Next. Now, coming back to the history where discovery of graphene. Now, discovery of graphene, as we know that these are the two scientists, Andrei Zim and Novoselov, in 2010, they set a Nobel Prize in Physics for discovery of that graphene. Graphene is a single layer sheet, okay, two-dimensional sheet where it is an atomic layer of sheets, where hexagonal honeycomb shape of carbon atoms. So, which can be synthesized either through exfoliation method, okay, which is also called as Scotch tape method, or which is also referred as peel-off method. So through which we can synthesize from graphite. Graphite is a multi-layer sheet. From graphite to graphene, the graphene is a single layer sheet, two-dimensional sheet. So through this exfoliation method, we can easily synthesize. So these are the various characteristics of graphene. What are the characteristics? It has a high surface area, which is around 2,600 meters square per gram. It is a very lightweight material. It is very lightweight, and the strain which is comparable to steel. Okay, that thermal conductivity is also very high. Thermal and as well as electrical conductivity is also very high because of this single layer sheet where the carbon which is in sp2 hybridized states. So due to the pi electrons, it has a high thermal conductivity as well as electrical conductivity. It has a porous structure and which has also high tensile strength. Next. Now look at this. Through graphene, graphene is an inert material. Okay. So how to functionalize it? So to functionalize the graphene, through number of oxidative debris created on its surface or on the edges sides, then this is called as graphene oxides. Okay. So graphene is an inert material, but to convert them into graphene oxides, where this graphene oxide have a number of oxidative debris on its basal plane and on the edges sides. So specifically carboxylic group found on the edges sides, however hydroxyl and epoxy groups, they are found on the basal plane. Now to differentiate graphene and graphene oxides, look at this Raman spectra. So graphite is a single layer seed, okay, where while taking the Raman spectra, it gives a single peak around 1580, which indicates that this is a carbon skeleton, planar carbon skeleton. However, the new peak is observed while it modified with number of oxidative debris. So that peak observed around 1380. So that may be due to, which indicates that certain defects are generated on the planar structure of that graphene. So due to the generation of defects, the new peak arise, which is Raman active, that is observed around 1380, which indicates that number of oxidative debris would be created on its basal plane or on the edge sides. Now, the history of graphene oxides. So, starting from Broidy. So, Broidy matter, first time introduced that graphene oxide while using graphite, fuming HNO3 and KClO3. So, this matter for the synthesis of GO, this is one of the first matter which is very slow process, okay, and hazardous matter because KClO3 is used. Followed by, in 1898, Strootmaier, where he has used graphite, fuming HNO3 and concentrated H2SO4. However, this compared to the previous matter, which is one of the improved matter for the oxidations, still high oxides of nitrogen generation would be observed. Then followed by Hopnin in 1937, they have introduced another matter where he has used graphite, concentrated HNO3, H2SO4 and KClO3. So this is mildly improved matter, but still it is hazardous matter due to chlorates and nitrates, uses of chlorate and nitrates. And then after the most important matter, that is Hummers matter. So Hummers matter in 1958, Hummers have used graphite, concentrated H2SO4 and NNO3. This matter which is considered to be one of the faster matter, more efficient, and absence of KClO3 which have lower explosion of bricks. Then after, in 2009, the Sen has introduced another matter where used graphite, benzoyl peroxides. This is nitrogen, NO3 free matter, milder oxidations. Okay, the oxidation would occur very mild and better quality. Followed by this Marcano matter in 2010, he has used graphite, phosphoric acid, concentrated H2SO4 and KMNO4. So this proposed matter which is used for large scale, time efficient matter for the production of graphene oxides. Because this matter, Marcano matter, which became the modern standard for high quality of graphene synthesis, graphene oxide synthesis. Now next. So we have used this modified Hummers matter while taking a graphite powder along with NaNO3 and concentrated H2SO4 and stirring to in ice bath for 2 hours and followed by stirring in water bath at 35 to 40 degrees centigrade temperature for 2 hours and then followed by addition of distilled water and increase the temperature up to 90 to 98 degree and then addition of hydrogen peroxides. Finally, we are getting the brownish color solutions of graphene oxides. Okay, centrifuge the solution and drying at 60 degrees Celsius. Finally, we are getting the graphene oxide seed. Next. So, I have taken up a few series discussed here. The first one, that series published in the Diamonds and Related Materials. One of my students, that Ravi Vitlani, has modified selective oxidative debris on the surface of GO. So there are various oxidative debris on the surface of GO, like hydroxyl group is there, epoxy is there, carboxylic group is there. So out of them, which one we have to modify? So accordingly, we have tried that. So first we have modified the hydroxyl group selectively using APTMS. Next. So here in this work, where after synthesizing the graphene oxides, we have used APTMS, aminopropyl trimethoxysilane, and based on that, the hydroxyl groups are only functionalized, okay, and created this debris over the surface of graphene oxides, followed by addition of 2-hydroxy acidophenol and followed by metal salt solutions, and finally we are getting the final compound. So this complex compound standard on the surface of that graphene oxides. Next. So this compound was characterized through various physicochemical techniques like FTIR, where the GO graphene oxide FTIR, where the broad peak around 3,389 and the peak around 1,722, which indicates that the carbonyl group, okay, and 1057, which indicates that the epoxy group. After functionalization with APTMS, this peak was slightly decreases. So which indicates that the hydroxyl group functionalized with amino group, okay. However, the peak around 1,722 said carbonyl peak will remain intact. So we have selectively modified the hydroxyl group. We can confirm through the FTIS spectrum. So here, the XPS, which reveals that the first one, which indicates that the graphene oxide seed, where we are getting the surface spectra, carbon and oxygen, which reveals that number of carbon atoms are present and number of oxidative debris are also present. Here, while modifying it, the new peak is observed, that is due to the amino group that we have introduced through APTMS. Okay. Along with that, silicon peak are also observed. Silicon 2s and silicon 2p peak are also observed. So we can confirmly say that the APTMS group functionalize over the surface of graphene oxide. Now look at this, the Raman spectra. The Raman spectra, the first one, which is for GO, the two peaks are observed, one around 1,580 and second one which is around 1,380. So the intensity of G band, intensity of D band. So after functionalization with APTMS, the defects would be more. Okay, so defect would be enhanced. So how to confirm it? While carrying out the intensity of D band and intensity of G band, ID by IC ratio, so it would be increases while compared with the GO. So GO, where ID by ID ratio would be around 0.98, after functionalization with APTMS, that the ratio increases up to 1.04. Okay, so followed by, while introducing the metal complex, that defects further enhances. So that intensity ratio, ID by IG ratio, further increases up to 1.10. So which reveals that the defects would be generated. Okay. And how we have confirmed that the only hydroxyl group be only functionalized and not epoxy or not carboxylic group. So with the help of density functional theory, theoretically we can prove that. So these are the only hydroxyl group which has a value of binding energy minus 0.972, and while which is comparable with the amino group. So only hydroxyl group will be functionalized with APTMS and not carboxylic. Their values are slightly higher, and therefore only one group which is more susceptible for the functionalization with APTMS, that is hydroxyl group. Next. These are the SAM and TAM results. So SAM and TAM results which indicates that, so it has a multi-layered laminar structure of GO and metal skip base functionalized GO. And based on that, the thickness of GO was slightly increased after functionalization with APTMS or functionalization with metal complexes. So which reveals that certain groups would be created over the surface of that GO. So therefore the thickness of the GO sheet would slightly increases. Yes, next. Okay. So that compound we have applied for that catalytic study. So we have used these benzyl alcohol oxidation reactions with the help of the catalyst. So what we have observed that while optimizing the parameters, while varying the molar ratio, while changing the catalyst amount, solvent, time, we got the exceptional results where around 99.67% conversion was observed. Okay. And we can recycle up to 4 times. So this catalyst was recyclable up to 4 times without loss of activity. Next. Hello. Now, in previous study, we have functionalized selectively hydroxyl group. Now here, we have selectively functionalized carboxylic group. So how we have functionalized this carboxylic group? So we have used the SOCl2, thionyl chloride, so that it will react with the carboxylic group and formation of COCl. Okay. So previously we have functionalized hydroxyl group. Here we have functionalized carboxylic group. And while using SOCl2, it will convert into ClFgO. Now this ClFgO followed by adding ligand and the metal salt solution, and finally we are getting the metal complex which are tethered on the surface of the graphene oxides. Next. So this route is actually not a viable route. Why? Because while we apply the catalytic reactions, okay, so the catalytic conversion was sharply decreases. So what could be the reason behind them? Because while we functionalize the carboxylic group with SOCl2, okay, so their acidity would be drastically decreases. So their acidity would be drastically decreased. So this catalyst, the conversion only 5.10. Okay, so this is a poor performance might be due to the lesser acidic sites. So that we observe that while selectively functionalized carboxylic group with the help of SOCl2, where the acidity would be drastically decreased, in that case it would be catalytically inactive. Okay, so how to improve the catalytic? So we have add trace amount of H2SO4 and to check that. So after adding traces amount of concentrated H2SO4 as a precursors, where the conversion sharply increases. Next. So look at this. While adding the trace amount of concentrated H2SO4, the conversion and selectivity drastically increases. So which indicates that while selectively functionalized carboxylic group with the SOCl2, the acidity of that compound decreases. Okay, and that was published in the Journal of Molecular Structure. Now another series where we have used the Fe nanoparticles anchored on amino-modified reduced graphene oxide nanoseeds as a bifunctional catalyst and used for the novel condensation reactions. So that was published in the New Journal of Chemistry. Next. So this is how we have synthesized this catalyst. Here, after synthesizing graphene oxides, followed by adding either aniline or paraphenyl diamine. So in this way, we can modify this GO with aniline modified or paraphenyl diamine, followed by reduction with NaBH4, sodium borohydride, and FeCl3. So the Fe will stick to the surface of that GO. So the catalyst which is referred as Fe nanoparticle PPD-GO, RGO, or Fe nanoparticle PPD RGO. Okay, next. So these are the results.
Modi sir,
we have confirmed that this catalyst was synthesized or not. Okay, so we just keep this slide.
Chetan, try to expedite.
Yeah. Yes. Next. Okay. So these are the results of TEM. Okay, next.
We have 5 minutes with us.
Oh, sorry. So I have to skip some slides. Okay. Here we have used prepared a catalyst and used for catalytic reaction Henry and Aldol condensation reactions. Okay. Yes. Next. Okay. Here in this series, we have synthesized the beta nitroamines via nitromanganese reactions using neodymium APDMS decorated graphene oxides. And that was published in the Journal of Molecular Catalysis. Next. This is how we have synthesized the catalyst. Go back. Yes. These are some of the results through which we have synthesized neodymium, APDMS modified geo. So, through these results, I will skip this slide because due to time constraint. Yes, next, please. Next. These are the results where we have used the benzaldehyde and nitromethane to get the product. So the red highlighted text which indicates that this is the maximum conversion and selectivity while taking the catalyst 90 milligram and temperature would be around 85. Okay. And these are some of the derivatives that we have used. Okay, next. Slow. This is the last series that instead of GO, here we have prepared composites actually. So this composite that we have used for novel gel condensation reactions, visible light driven novel gel condensation reaction use it functionalized graphene oxide, Fe3O4 and graphitic carbon nitride heterojunctions. So here we have prepared the heterojunctions using the three component graphene oxide, Fe3O4 and graphitic carbon nitride, and which is used as a photocatalyst. And yes, next. This is how we have synthesized the catalyst. Okay, I will skip this. Here, look at this, the XRT patterns which prove that Fe which is present in the Fe3O4. So these are the prominent peak that we observe for Fe3O4. So which is matched with the JCPDS data, which has a FCC structure. Okay. These are the UV-DRS spectra, UV visible. So diffusion reflectance spectra, which reveals that the graphene oxides, graphitic carbon nitride, where the peak around 375 nanometer, and in case of Fe3O4, the peak around 420. Okay. So after functionalization with EDG, so FEGCN, that the peak shifted in the red shift, that means more visible region, and followed by adding EDG FEGCN. So in that case, it would be shifted towards longer wavelength, which indicates that this is photocatalytically active species. Now here, these are the talk plots, which is optical band gap energies. Here for the final catalyst, which is around 1.68 electron watt as compared to FEGCN, so which is around 1.75 electron watt. So which indicates that the band gap between conductance band and valence band would be decreases further, which is considered to be a more catalytically active species. These are the band for Fe3O4 and this is for GCN. Okay. This is the electrochemical impedance spectra, Nyquist plot of the synthesized material, where which it depicts the radii of semicircle arc corresponding to the resistance of the photocarrier charge transfer. Now, if the semicircle arc which are larger, which indicates that this is photocatalytically inactive. If the semicircle arc radii decreases, which indicates that it is more photocatalytically active. So these are the pristine compound, the GCN, which has a larger semicircle arc as compared to the final compound, which are of having very narrow semicircle arc, which is considered to be a more photocatalytically active species. So, and these are the some data that we have carried out in light conditions and dark conditions, without light and with light. So these results which indicates that in light conditions which are having exceptional results as compared to the dark conditions. These are the Morse-Koski graphs which indicates that the positive slope of this value, which indicates that these are working as semiconductor, okay, and which is considered to be N type of semiconductors. And intercept on the x-axis, which represents the fat plane, this is the flat band potential value. So EDG, that is ethylene diamine modified graphene oxide, which enhances the charge carrier density, leading to the excellent photocatalytic activity. So in FEGC, and while we are adding furthermore EDG, that is ethylene diamine modified graphene oxides, so it enhances the movement of electrons. So it would be considered to be a more photocatalytically active species. Next. So these species we have applied for these photocondensation reactions. So benzaldehyde and malonitrile, while using this catalyst, the final product, that is benzalidine malonitrile, were observed. So the red text which indicates that these are optimized conditions where while taking the 100 milligram of that catalyst, the light source would be the 200 watt light white LED in ethanol solvent within a very shorter period of time, only 45 minutes, the conversion greater than 99.9%. However, selectivity would be around 98.51%. So, what are the key achievements for these reactions? So, we have finished in short duration time, within 14.5 minutes, the reaction would be completed with exceptional results, more than 99.9% conversion and 98.5% of selectivity. We have used white LED source, so 200 watt white LED source, and using this source, we got these results. We have also used the ethanol as a grainer solvent. So these are our key achievements. Next. These are some of the derivatives that we have used, benzaldehyde derivatives. Now this is a proposed mechanism how these photocatalysts work. So here, look at this. This is the valence band and the conductance band of graphitic carbon nitride, and this is the valence band and conductance band of Fe3O4. Okay, so both these are work as a type 2 heterojunctions. While the EDG, that is ethylene diamine modified graphene oxides, which act as a promoter. Okay, so mediator. So while light fall on the graphitic carbon nitride sheets, then electron hole generation would occur. So the electron will promote it from valence band to conductance bands. Right? Now what is the role of EDG here?
Modi
So
sir,
EDG.
Modi sir, please go to conclusion.
This is the last one. The electron would be generated on the surface of graphitic carbon nitride. It will easily transfer to the surface of Fe3O4 via EDG, that is ethylene diamine modified graphene oxides. So now this electron combined with oxygen and generation of superoxide species. So these superoxide radicals, now the reaction would start with malonitrile. The malonitrile here, which is an active acidic species, where the superoxide anion, which breaks the carbon-hydrogen bond in malonitrile, followed by deprotonation would occur, and this species followed by the base catalyzed route, finally we are getting the product. Okay, and on the other side, this hole would be easily transferred to the graphitic carbon nitride surface. So from Fe3O4 surface to graphitic carbon nitride surface through this mediator, and this is how this peroxide species, while it reacts with the holes and converted into O2 and generation of H+. Now this O2 again react with electrons and the cycle continues. So this is how this heterojunction works. Okay, so these are the type 2 heterojunctions. Both are type 2 heterojunctions. If we are taking only one, so this recombination rate would be higher. So to minimize such issue, that we have synthesized these heterojunctions. Now next. So this is my last slide. Look at this, every brilliant experiment, like every great work of art, start with an act of imaginations. Thank you very much for your kind patience.
Thank you, Professor Modi, for a wonderful lectures.
So
you have
this is my lab, catalyst. These are my students. 9 students, they have completed their PhD, and 5 are still working.
Your group is very active group, particularly in the applied chemistry area. So friends, if you have any quick questions, please because this is again one of the very important area of research you can pursue at simple laboratory also.
Thank you, sir, for your enriching and knowledge-enhancing presentation. I request the chairperson to kindly felicitate Dr. Chetan Modi, sir, by offering the memento as a token of love and gratitude. I request Dr. Aswal, sir, please be on a dais. Thank you, sir. Sir, kindly please felicitate Dr. Modi, sir, by offering the memento as a token of love and gratitude. Thank you, sir. As we come to close the technical session 1, I now request Dr. Nilesh Thakre to propose the vote of thanks.
Thanks, Mantu. So, friends, we have realized all the three distinguished speakers, how they have delivered their talk in a illicit language, make their presentation very simple. And this is one of the aim also of conference, to learn these things from the distinguished speakers, how they have made their PPT also simple, step by step, fundamental to application also. And you can interact with this researcher also. All these three people are very simple, accessible. And personally, I had an experience to visit their laboratory. So how they have developed their research laboratory, very simple. We cannot compare with NCL or IIT also. Just simple our college laboratory, Sri Shivaji Science College laboratory also. Particularly, I had been to Patel Sahab laboratory as well as Chetan laboratory also. And I know him, how he has prepared the simple skip-based complexes to today's graphene, which is the allotrope of the carbon. Kodsa, diamond, and graphene. These are the allotropes and how he has used also. So, which is the most relevant to the themes of your conference. E-cube, I can say particularly. And as we know, for the progress and development of any nations, we need the 5 E's also. And I may quote here that these 5 E's are nothing but the economy, energy, efficiency, ethics, as well as environment also. So all these 5 E, I may say, the adhere with this, all these three speakers also, and they have nicely delivered their talk. So once again, I must congratulate the organizer, particularly Prashant, as well as Nagpure sir, Gajanan Korpe, who is also again my student, and I must express the sincere thanks for giving me this opportunity, though I was not reluctant to come here, but as I mentioned earlier, it was their love and affection brought me here. So I must thank the Jagruti also, Dongre, as well as Hemant also, who was also again my very close friends also. But this is occasion where I can meet my student as well as the senior also. That was the only aim to came over here, though I am not feeling, I may say, the well also. So once again, thank you. And I must congratulate your active participation, constructive discussion also, and patience listening also. Otherwise, it is very difficult for a speaker to talk also. Sometimes to find the audience also. So we are lucky that we got a several audience, and hall is almost 2/3 compact, as well as your enthusiasms also reflect also. So thank you once again to all of you, and thank you organizer for this opportunity.
At the outset, I pay homage to Dr. Panjabrao Alais Bhausaheb Deshmukh. First of all, I express my sincere thanks to chairman of the session, my teacher, Dr. A.S. Aswar sir, ex-head of the department, SGPU Amravati University, Amravati. I also extend my thanks to speakers of the session, Dr. Hitendra Patel sir, Professor, Department of Chemistry, SP University, Anand, Dr. Kushal Bhatte, Senior Scientist, NCL, Pune, Dr. Chetan Modi, Professor, Department of Applied Chemistry, MSU, Vadodara. Lastly, I convey my thanks to Senior Professor, my colleagues and research students for attending this session and contributed in the lively discussion. Thank you.
Thank you. So I was forgotten to acknowledge particularly Nitin as well as Harshali also for the nice introduction. And it is our tradition always आहे ना, पाहुण्यांचं स्वागत आपल्याकडे माहिती आहे, आपली थट्टा कशी आहे, शब्द चांगलेच चढून ओढायचे असतात. सो आय मस्ट थँक टू नितीन ऑल्सो फॉर वंडरफुल इंट्रोडक्शन्स. थँक्यू.
Thank you, sir. So I request all those research scholars who are going to present their oral presentation, please submit your PPT to the technical committee. Because after this session, right now, within a few moments, the oral presentation will be started. So thank you so much, sir. With this, we formally conclude the technical session 1. Thank you all for your presence, attention, and academic enthusiasm. We look forward to your participation in the session ahead. Thank you so much. Now, for the next session, I'll call upon Dr. Shruti Ingole.
National Conference of Earth Elements and Energy. Welcome back, everyone. Let's move to the oral presentation session, a space for insightful research in chemistry. I, Ms. Shruti Ingole, on behalf of the organizer, extend a warm welcome to one and all. Each speaker has 5 minutes for their talk and 2 minutes for discussions. It's our immense pleasure to have eminent personality in the field of research, respective Professor Dr. H.S. Chandak sir and respective Professor Dr. M.G. Dhonde sir as a jury members for oral sessions. I kindly request them to please occupy a seat on the dais. So please. Welcome, sir. Respected Professor Dr. H.S. Chandak sir is a professor and head of the Department of Chemistry, GS Science, Arts and Commerce College, Khamgaon. He has published many research papers in renowned journals with high impact factor in the area of heterocyclic chemistry, computational chemistry, green chemistry and catalyst, etc. He is the chairman of Board of Study at Sant Gadge Baba, Amravati University, Amravati. Again, I extend a warm welcome to you, sir. Our next juries of this session, respected Professor Dr. M.G. Dhonde sir, Professor and Head, Shri Mathurdas Mohta College of Science, Nagpur. He has a great contributions in the area of organic synthesis, heterocyclic compounds, drugs and catalytic synthesis, etc. Welcome, sir. I would like to invite convener of this conference, NCE 3IP 2025, Dr. Pia Malik sir, to welcome Professor Dr. H.S. Chandak sir by offering sapling and memento. Thank you so much, sir. I would like to invite Dr. Anna Thakre sir to welcome Professor Dr. M.G. Dhonde sir by offering sapling and memento. Thank you so much, sir. Honorable members of the judging panel, you are kindly request to occupy a seat. Welcome, sir. With best wishes to the oral participants and with the permission of jury's member, I would like to call a first speaker. Palak Bhattad. Please come here. Please deliver your presentation, ma'am.
Hello. Okay, have you ever wondered how your phone, laptops, or even solar cells manages to work more efficiently by each passing year? Good afternoon all, myself Palak Bhattad, Senior Research Fellow working under Professor Sanjeev S. Zade at Department of Chemical Sciences, IISER, Kolkata. So today in this presentation, I'll be taking you through the history of organic electronics, the work people have done so far and what we are doing. But before I dive straight into the topic, let me tell you how the field has been started. So it dates back to 1950s when chemists have suddenly discovered that organic compounds can conduct electricity. Then in late 1970s, the discovery of polyacetylene conductive polymers lead to the Nobel Prize to Sir Allen Heeger, Alan MacDiarmid and Hideki Shirakawa in the year 2000. Now what is something so great about this field? This field showed us that organic compounds can conduct electricity. It also showed us that electronics need not to be rigid. It can be flexible, cost-effective, lightweight, printable, and even wearable, and therefore have variety of applications such as organic field effect transistors, organic light emitting diodes, and organic solar cells. Now I don't have like expensive silicon fabrication machineries or cost making chips, but what I do have are small molecules that I can tune, modify, and design just like I want. Now this is the beauty and the beast in that sense, because a small change in the molecules can work beautifully or can completely fall apart. So organic semiconductors can be classified into two types, polymers and small molecules. But we have chosen to focus on small molecules because small molecules can be synthesized with high purity. They have better control over molecular structure and properties, and also they can be synthesized with high order crystallinity. Whatever examples you are seeing on the screen are well-known examples from the literature of small molecule organic semiconducting material that act as P-type semiconductors in their organic field effect transistor channel, and these are the whole mobility values for these molecules. Now, P-type semiconductors are well developed, but the N-type semiconductors are lagging behind, and the reasons behind their lagging is higher barriers to charge injection, lower stability of reduced state compared to oxidized states, and presence of electron traps. Electron traps could be anything because an ion formed after electron injection can be easily oxidized by oxygen or water. But there is a solution to the mentioned problem, and what we can do about this is we can lower down the energies of LUMO. We can also introduce some electron withdrawing groups such as amide, amide, nitrogen boron unit, and the cyanide group. We can also prevent oxygen and moisture from penetrating into molecular backbone. There is one more secret ingredient to the recipe, and that is we can introduce the heteroatom to the pi conjugated core. And with all these results, we can increase the electron mobility value as high as 1.44 centimeter square per volt second in air and 5 centimeter square per volt second in vacuum. Now with all these ideas in mind, such as a core should be polycyclic and pi conjugated, we should introduce the electron withdrawing group like imide, we should decorate the pi conjugated system with the heteroatom, and design should be done considering the crystal packing. We have chosen acinaphtine as our target core. Now acinaphtine, because of its non-alternatant aromaticity, planar structure, and tunable chemistry, can act as an efficient candidate for organic semiconducting material. Several derivatives of acinaphtine such as decacycline, coranulin, and fluoranthene are already proven to be a good P-type semiconductors. But our aim was to synthesize the N-type semiconducting material, and for that purpose, we thought of introducing triazine unit on our acinaphtine core. Now, two isomers of triazine such as 1,3,5-triazine and 1,2,4-triazine are already well explored, but 1,2,3-triazine is less explored, and therefore with that thought, we have designed a synthetic outline where we are starting with 1,8-diamino-naphthalene, and 1,8-diamino-naphthalene on treatment with sodium nitrate in presence of acetic acid and hypophosphorus acid leads to molecule 2, that is naphthotriazine. We have further done the alkylation of molecule 2, and we got two isomers, 2 alkyl naphthotriazine and 1 alkyl naphthotriazine. Now both these isomers structurally look similar, but they absorb at two opposite extremities of the electromagnetic spectrum. Anyway, that is not part of our discussion today. We were specifically interested in molecule 3 because molecule 3 shows very unusual cycloaddition reaction, that is 1,11 dipolar cycloaddition reaction. And therefore, we have done the cycloaddition reaction of our 2-alkyl naphthotriazine with acetylene dicarboxylate to get molecule 5. Further, we have done the hydrolysis followed by decarboxylation of molecule 5 to get the molecule 6. Now, as this cycloaddition reaction was very unusual, we thought of doing the mechanistic study for this molecule. And unlike usual cycloaddition reactions which generally undergo through concerted mechanism, ours was going through the stepwise mechanism with two well-defined, 2 minutes please, with two well-defined transition states. This mechanistic study has been done using density functional theory at the M062X level. To extend the further pi conjugation of our synthesized molecule, we have decided to done the dimerization of molecule 6 using acetic acid and hypophosphorus acid, and we got dimer 7. Upon confirming the dyne properties of molecule 7 by using DFT and looking at the HOMO and LUMO orbitals of this molecule, we have done further cycloaddition reaction of molecule 7 with commercially available potential dienophiles such as tetracyanoethylene and acetylene dicarboxylate to get target molecule AN1 and AN2 with 85% and 55% yield respectively. Now all these novel synthesized molecule in this series shows good absorption in the visible region ranging from 400 to 600 nanometer. On studying the optical and electrochemical properties of our final molecules AN1 and AN2, we found that the tetracyanoadduct absorbs in the range of 560 nanometer, and upon extrapolating the linear region of tau plot, the calculated band gap is 2.1 electron volt. And the electrochemical studies gives the HOMO-LUMO value of minus 5.35 electron volt and minus 3.56 electron volt respectively. While the acetylene dicarboxylate adduct absorbs in the range of 460 nanometer and the calculated band gap is 2.56 electron volt. So this brings me to the end of my presentation, where we have successfully synthesized series of novel molecules, and upon studying their optical and electrochemical properties, we found that this molecule can be a potential candidate as N-type semiconductors in organic field effect transistor channel. Now before I end, this is our beautiful campus. You all are welcome sometimes. And with that, I'll be happy to answer your questions. Thank you.
Topic is open for discussion.
Hello.
This one, sir. So the idea behind introducing the triazine group is its electron withdrawing nature. Like we wanted to incorporate the nitrogen atoms so that it can lower down the LUMOs. Yes, sir. So I think it would not be depend on symmetry. Yes, sir. Means I think it should not be depend on symmetry, or yeah, it should be depend on how many heteroatoms we are introducing. Yes, sir. As this symmetrical, like 135 triazine are already there, well explored in the literature. That's why we have choosing the 123 triazine.
They are easy to synthesize also.
Yes, sir.
Anyway, your aim was to introduce nitrogen, right?
Yes, sir.
So it doesn't make sense whether you are having
Symmetry, yes, sir.
Okay, thank you.
Thank you. Next participant, please be ready for the presentation. I repeat against a rule. Each speaker has 5 minutes for their talk and 2 minutes for discussion. Please submit a soft copy for a presentation, those who have not submitted. A soft copy for your presentation in the format of PDF and PPT both. Now, next participant is Dr. Vishal Rathod.
Good afternoon,
all the judges and all the participants and my respected supervisor and all the mentors of Sri Shivaji Science College. Myself Vishal Rathod, Dr. Vishal Rathod, and today I am going to present the oral on the topic of nickel dope and undoped manganese dioxide nanocrystals synthesized via hydrothermal method for supercapacitor application. The introduction of supercapacitor, the transition metal oxides emerge as a promising electrode material for next generation supercapacitors due to their rich redox chemistry, environmental compatibility and cost effectiveness. Among them, manganese dioxide has attracted significant attention because of its high theoretical capacitance, natural abundance and versatile crystal structure. Nickel is particularly attractive as a dopant due to its multivalent oxidation state, ability to enhance electron transport and structural stability. The hydrothermal synthesis method offers a simple, controllable and scalable route to produce a manganese dioxide based nanocrystals with well-defined morphologies and improved crystallinity. This technique allows for uniform nickel incorporation into the manganese dioxide lattice, resulting in enhanced physiochemical properties. By comparing nickel dope and undoped manganese dioxide nanocrystals, valuable insights can be gained into the role of doping on electrochemical performance and charge storage mechanism. Therefore, this study totally focuses on the hydrothermal synthesis of nickel dope and undoped manganese dioxide nanocrystals and evaluate their structural morphological and electrochemical characteristics of supercapacitor application. The objective of this research is to synthesize nickel dope and undoped manganese dioxide crystals using controlled hydrothermal method to characterize the structural, morphological and compositional feature of the synthesized nanocrystals, to investigate the electrochemical properties of nickel dope versus undoped manganese dioxide electrodes, to evaluate the effect of nickel doping on charge storage capability and cycling stability, to determine the suitability of nickel doped manganese dioxide as an electrode material for high performance supercapacitor. So the methodology I can use to synthesize these manganese dioxide nanocrystals by the use of various chemical composition, for example, potassium permanganate, manganese sulfate, citric acid and different surfactant I can use for synthesizing these nanoparticles. Then after that we can get the characterization like a UV, XRD, XPS, same TEM and BET analysis. So the results and discussion. The XRD pattern of a nickel dope manganese dioxide show a slight peak shifts compared to undoped manganese dioxide, confirming successful incorporation of nickel ions into the manganese dioxide lattice. Then same time images reveal nanocrystals with uniform morphology, while nickel doping produce a smaller and more interconnected particles, contributing to improve ion diffusion. So these are the figures of same time as well as XRD pattern. Then the electrochemical analysis of the series of MR1, MR1D1, D2, D3 samples were assessed using cyclic voltammetry with 1 mole per liter of sodium sulfate electrolyte over a potential window of 0.00 to 0.60 volt at a scan rate of 5 to 100 millivolt per second. The distorted CV curve confirmed the pseudocapacitive energy storage mechanism. MR1D2 demonstrated the highest specific capacitance due to its uniform porosity and high surface area, excellent electrical conductivity. So this GCD curve is also shows the high specific capacitance of MR1D2 sample. Then the conclusion, we successfully synthesized the pristine and nickel doped manganese dioxide nanostructure material with varying nickel concentration using a hydrothermal method. The electrodes made from both pristine and nickel doped manganese dioxide demonstrated excellent electrochemical performance in 1 mole per liter of the sodium sulfate electrolyte. Then notably, the 4% of the nickel dope manganese dioxide electrode achieve a high specific capacitance like a 432.5 Faraday per gram at a scan rate of 5 millivolt per second and show a remarkable durability retaining a 96.65%. Thank you.
Discussion.
They can enhance their morphology. Due to this doping of nickel, the morphology of nanocrystals can be strengthened, or so they can improve the electrochemical parameters like a specific capacitance of CV, GCD, impedance spectroscopy. Thank you, sir.
Thank you, sir. I would like to call a next participant is Sakshi Parat.
A very good afternoon to one and all present here. I am Sakshi Bharat, PhD student under the guidance of Dr. Atul Wankhede, Department of Chemistry, Vishveshwaraya National Institute of Technology, Nagpur. And today I am going to give a presentation on topic in situ ZNS formation on oxygen-tuned zinc oxide for enhanced photocatalytic hydrogen evolution. So we all know the climate story. Rising temperature, stricter emission targets, and energy uncertainty. But instead of repeating the problems, let me show you the opportunity. Hydrogen. Why hydrogen? It is clean and it exhausts only water. It is highly efficient and it is used everywhere from vehicles to industries. But 95% of the hydrogen is produced from the fossil fuels. So can we split water into sunlight for hydrogen evolution? So this is the overall mechanism of the water splitting, in which when the visible light falls on the catalyst, it generates electrons and holes. So if it separates well, then electrons produces hydrogen and holes makes oxygen, and it needs the energy of 1.23 electron volts. So today I am going to talk about how a small structural modification can, by just removing oxygen molecules, can change ZNO, can make ZNO as efficient photocatalyst for hydrogen evolution. Because of the time constraints, I will focus on my main results only. So ZNO is synthesized by pure ZNO is synthesized by a simple method of hydrothermal, and then it is annealed at ZNO 400, 600 and 800 after formation of the pure zinc oxide. For oxygen deficient zinc oxide, what we did, we introduced hydrogen peroxide in the reaction, and the ZNO gets converted into ZnO2, and after annealing at 400, 600 and 800 degrees Celsius, oxygen deficient ZnOx 400, 600 and 800 is synthesized. So because of this peroxide ions, they breaks, because of this peroxide ions get breaks and oxygen is evolved, which creates vacancies. But these vacancies are not defects, they are features just like holes in fluid which make music possible. So, engineering the oxygen vacancies in ZNO destroys the structure of pure ZNO, the XRD confirms that answer is clearly no, because we can see in all the ZNO samples, pure ZNO phase is formed, but in ZNOx samples, in ZNOx 400, we can see peak broadening is there because of the lattice distortion, which proves that oxygen vacancies are created in oxygen deficient ZNO sample. In UVDRS, we can see because ZNO is UV active, after creating oxygen vacancies, we get a visible active ZNOx, and in ZNOx 400, we can see a band gap is 2.91 electron volt, which is visible active and which helps it for photocatalytic hydrogen evolution. Same story goes with the Raman spectra. In Raman, we can see ZNO peaks are formed in all the samples, but defect peaks are because of the oxygen vacancies are created only in ZNOx sample, and in ZNOx 400 we can see in magnified image that in ZNOx 400 strongest peak is observed, which represents that 400 degrees Celsius temperature facilitates the optimal oxygen vacancy creation in this oxygen deficient ZNOx. XPS proves that in ZNOx samples, in oxygen 1s spectra, we can see peak intensity increases, which proves that oxygen vacancies are formed. Also in ZN2P, peak shift confirms that there is a change in the local bonding environment of this ZNO. FESEM spectra proves that the nanospheres are formed and they are intact. In ZNOx, we can see a rough surface because of the lattice distortion. EDS proves that zinc and oxygen is present and no other impurity is present. And HRTM, we can see that lattice fringes are present, which proves that crystallinity is preserved. So here is the heart of our research. We measure the amount of hydrogen which is evolved using GC with DID detector, and we optimize various parameters in 50 ml of the distilled water. We optimize platinum solution, which is 80 microliter, which is optimized, and which shows high hydrogen evolution, 10 mg of the photocatalyst, and 0.2 molar Na2S and Na2SO3 sacrificial agent, which gives highest hydrogen evolution, results. So these reaction conditions are applied, and we can see in ZNOx we are getting highest yield. Also it is stable. Also this material is stable up to 4 cycle. And after post-reaction of water splitting, we can see in situ ZNS is formed because ZNS peak appear in XRD. Also sulfur is present in EDS and in FESEM on ZNO surface, and zinc and sulfur bond is present in XPS, which shows that in situ ZNS is formed on ZNO, on oxygen deficient ZNO. So here is a plausible mechanism of the water splitting, which here we can see p-n heterojunction is formed between ZNS and ZNO, and it for enhanced photocatalytic hydrogen evolution. So these are the comparative data. Our sample shows highest hydrogen evolution result. These are the references which I followed. Lastly, I would like to conclude that we have successfully synthesized in situ ZNS on oxygen deficient ZNO for enhanced photocatalytic hydrogen evolution. And lastly, I would like to conclude that even a small atomic change can make a big clean energy impact. So lastly, I would like to conclude Department of Chemistry, VNIT Nagpur, my guide Dr. Atul Wankhede, Shivaji Science College, Amravati, and organizing committee of the conference for giving me this opportunity. Thank you.
Topic is open for discussion.
by gas chromatography. We calculated it in micromoles. If we have, sorry.
You have oxygen vacancy, ne? So there is a less number of oxygen than required to satisfy the zinc valency. Ne?
No, sir, it is not like that. Like ZNO gets converted into ZnO2, and after annealing, oxygen get released and oxygen vacancies leave. Means
So-
ZNO structure is there. Pure ZNO structure is there. There is only lattice distortion which proves that oxygen vacancy is present.
So oxygen vacancy means you are basically, you need to compensate two negative charge of oxygen. Ne?
Yes, for like electron transfer, for creating a PN junction, because our aim was to synthesize in situ ZNS during reaction, during water splitting
So
reaction.
in this heterojunction, you have zinc oxide and zinc sulfide. Ne? Which one is a higher band structure? Which has
Zinc oxide, actually zinc oxide zinc oxide is producing hydrogen by taking electrons, and ZNS by taking holes they produce oxygen.
Okay, thanks.
So zinc oxide is, sir, band gap is 2.91 electron volt.
Okay, yeah, I understand.
I would like to call next participant, Dr. Chandrasekhar Ladode.
Thank you. Thank you. Hello. Good afternoon, all of you. My topic is study on catalytic development and characterization of mixed metal ferrites in organic transformation. So we all know about the ferrite. That ferrite material having the general formula that is MFe2O4. That is, it is a metal oxide, that is iron oxide with the transition metal oxides. So in these ferrites having the some property that is high resistivity, low eddy current, high saturation magnetization. So these ferrites having the two types. First is the soft ferrite, another is the hard ferrite. So soft ferrite generally the transition metal ferrites that is linked up with the iron oxide, and hard ferrite that is like the barium and strontium ferrite. So these ferrites have some properties that is ferromagnetic material, semiconductor in nature, cation distribution, that is A and B sides, and these spinel ferrites are used in the organic transformation, that is used as a catalyst, and this catalyst it is magnetically recoverable, reusable, and has stability and surface area. According to the crystal structure, these ferrites having the spinel ferrite, garnet ferrite, magnetoplumbite ferrite, and perovskite, and they are having the cubic structure, hexagonal and orthorhombic structure. So these are the crystal structure of the spinel ferrite having the A and B sides. Having again three types: normal spinel ferrite, inverse spinel ferrite, and random spinel ferrites. These garnet ferrites having the formula MFe5O12, magnetoferrites having the formula MFe12O19, and having the 6 types. These ferrite material are synthesized in various ways like cryoprecipitation method, sol-gel method, solid state method, solution combustion technique, and hydrothermal method. So as we know, these ferrites having the medical, cosmetic, catalysts, here we use the catalytic application, that is high surface area, easy to handle, structural stability, thermal stability, and reusability. This catalytic multi-component, this period using the multi-component reaction that like Hans reaction, Bignelli reaction, Manish reaction. Economic benefit of the catalyst, that is greener catalyst. Role of the catalyst, that is 24 from the GDP of the products made by the catalyst. As we know the catalyst role, that is it enhance the reaction. Share of the catalyst, that is heterogeneous catalyst, 80%, homogeneous 15%, and biocatalyst, that is 5%. We know the catalyst role, taking part of the in the reaction, altering the rate of the reaction, and finally returning to its the original size. So catalyst having homogeneous and heterogeneous. This homogeneous catalyst having the same phase, heterogeneous catalyst having the different phase. In this study, this catalyst is used in various reactions, that is multi-component reaction. Here we use the simple 3,4-dihydropyrimidine, that is Bignelli Hans reaction. This catalyst is characterized by various techniques, XRD, FTIR, TGDTA, same analysis. Study on catalytic development in organic transformation. Here the different reactions like ethyl acetate, aldehyde, and urea. We know the well-known reaction, that is Bignelli reaction. In this reaction, we also use this catalyst. Aldehyde, ethyl acetate. This is scheme second, scheme third. And use of this catalyst, that is it advantages of this, that is it is reusable, it with respect to the mild reaction conditions, shorter reaction time. This catalytic development in organic synthesis like Bignelli reaction, as already we know that. Here the XRD of the catalyst, FTIR, and TGDT of this catalyst. Same of this. Here we use the effect of different amount of this catalyst and solvents on the formation of the product. Role of this catalyst and comparative with the different catalyst, as how this catalyst is effective. In present work, by using the microwave, 95% yield in just 7 minutes. Here, synthesis of these 3,4-dihydropyrimidines once using this catalyst. Recycling and reusability of catalyst up to the 4 cycles. This is the spectral data obtained. Reference. Thank you.
Topic is open for discussion.
One simple query. 7 minutes reaction time, how do you monitor it, like 1 minute, 2 minutes?
In micro reaction, there is a time duration in that microwave. So, because this reaction is carried out in microwave.
So have you carried out the reaction for?
Synthesized microwave.
But 1 minute, 2 minutes, have you tried it?
Yes, sir. Yes, sir.
Minimum 7 minutes.
Different time and different reactor times.
Okay, thank you.
Thank you, sir. Thank you, the organizing team of this conference. Thank you.
Thank you, sir. Now, I invite respected Professor Dr. M.G. Dhonde sir for brief remarks. Okay, thank you, sir. I would like to request Professor Dr. H.S. Chandak sir. At the end of this session, I would like to thank respected Dr. H.S. Chandak sir for giving his valuable time and remarks that. Thank you so much, sir. I also would like to give my special thanks Professor Dr. M.G. Donde sir for being with us. Thanks a lot, sir. My sincere thanks to all presenters who delivered the oral presentation. Thank you so much. Last but not least, my gratitude towards the audience who kept their patience and active interactions during a session. Thank you all. On behalf of the organizing committee, I would like to announce that the oral session is over and to join for culture program which will be held in this hall itself. Thank you. सर्वांना नम्र विनंती आहे की या हॉलमध्ये सर्वांनी थांबावं. पुढला जो कार्यक्रम आहे तो सांस्कृतिक कार्यक्रम आहे. प्लीज सर्वांनी थांबा.
महाविद्यालयाच्या परिसरामध्ये विविध स्थानावरून आलेले सर्व सन्माननीय प्राध्यापक, त्याचप्रमाणे रिसर्च स्कॉलर यांना नम्र विनंती आहे की अवघ्या 5 मिनिटांमध्ये याच सभागृहामध्ये सांस्कृतिक कार्यक्रमाचे आयोजन खास आपणासाठी करण्यात आलेले आहे. तेव्हा या सर्व महाविद्यालयातील विद्यार्थ्यांचे कौतुक करण्यासाठी, त्याचप्रमाणे आपल्यासाठी इथे आयोजित केलेल्या खास मेजवानीसाठी आपण या सभागृहामध्ये उपस्थित व्हावे. विविध महाविद्यालयातून आणि विविध जिल्ह्यातून आलेले सर्व शिक्षक व रिसर्च स्कॉलर यांना नम्र विनंती आहे.